Hello my champions, welcome back to our channel Diksha Karnataka. Today in this class, in this one shot lecture, I'm going to cover up your another second PUC chapter, which is determinants. When I say I cover up, I mean that we'll complete each and every concept as per NCERT, as per your syllabus of CET and boards, and we'll solve questions of both the categories. Okay, CET, board style, everything will be discussed. So if you're excited for this session, let me know that in the comment section. Yes sir, we were waiting for this. Let's complete our chapter determinant in one class. I know you are feeling that, sir, I just finished my FA, for that I prepared my determinant. Good, that's very good. That gives us advantage that we'll be revising everything again with me in this class. But if you're thinking I have prepared it, I don't have to study the same chapter again, you are wrong. If you can solve each and every question from the PYQs comfortably for any chapter, it means you have prepared the chapter very good. You will just need to do a revision before your pre-boards, before your midterms, and before your finals, boards and CET, right? That's what the meaning of preparation is actually. But if you are getting stuck at even one point, it means it's good to revise it with this particular class. Okay, so yes. And again, for somebody who is feeling that, sir, this is going to be a long class, can I, have a alternative way to do that? Yes, it is. That is also there. This is a recorded lecture. Okay, I'll not try to waste your time over there. But even if you want to go and finish it fast, you can watch it at 2 times speed. You can watch the sections that you need to, revise or recall on. Getting it? Apart from that, you can also download the notes of this class and refer the notes and watch those sections that is helpful to you. So the point is not only to watch the entire lecture. Of course, if you can watch it, good, it'll be beneficial to you, but try to utilize the class for your benefit. In whatever way possible, try to make an output of this particular session. That's why I've given you this one-shot lecture of the chapter determinant. Makes sense? All clear? Okay, great. So we'll cover up theory, concepts, okay, of different, all the properties, alongside questions on both the categories. Moving on, let's move on. So starting from the very basics, which is what? Determinant. What is determinant, sir? Determinant is a scalar value associated to a matrix. Not good enough. What is the right answer? Determinant is a value associated to any particular type of matrix. Yes, and that matrix is called as square matrix. So for any square matrix, that scalar value you see, okay, that you can write for that, associate a unique real or complex number, that scalar value is called as determinant. Okay, now in our syllabus we have only two order of square matrix, 2 cross 2 or 3 cross 3. We don't have 4 cross 4, 5 cross 5. We don't have those matrix to find the determinant value from. Getting it? Okay, so we have to only take care of 2 cross 2 matrix. So if you have a matrix A which has the element A, B, C, D, determinant is given by same thing with a symbol of something very similar to what we had in modulus. And how do you find it? Cross multiply AD minus BC. So you get AD minus BC. And yes, this value can be positive and negative, both. We can't say this will be always positive or this will be always negative. Whichever is bigger, depending upon that, you'll have a sign like that. So if AD is bigger, it will be positive. If BC is bigger, it will be negative. That's why I said it is not modulus. Even though symbol looks like modulus, it is not a modulus function. The value of determinant can be negative, positive, either or both. Of course, not both for the same case. Clear? Getting it? Moving on. Now, how do you find this? So over here, I've written this value already. So for a 2 cross 2 matrix, you'll have A11, A22. Over here, A12, A21. You take cross multiplication, A11, A22 minus A12, A21. AD minus BC. This is for 2 cross 2 matrix. What about 3 cross 3 matrix, sir? Now over here, they can find determinant in how many ways? In actually 9 ways. Not 9, 6 ways. 9 only you can say. So 1, 2, 3, 6 actually, sorry, my bad. Yeah, 3 rows and 3 columns, na? So 6 ways. This is a 3 cross 3 matrix, so 6 ways. What is the meaning of that? It means you can find the determinant of the given matrix across either first row, second row, third row, or any of the 3 columns. I can find the same determinant matrix of the given matrix using 6 different ways and have the answer in each case same. I can expand using the row 1, the row 2, the row 3 or column 1, column 2, column 3. It does not matter, answer remains same. If you expand across row 1, then you'll have to expand across each element. So you'll have A11, A12, A13. This is A11. When you do that, you have to remove whichever element you are writing over here. You have to remove the row or column in which it is present. So A11 is present in which row? First row, first column. So remove the first row, first column. The remaining you write as determinant of 2 cross 2 order. Check here A22, A23, A32, A33. This is just for the first element. Check here. This will always be there. Minus 1 plus the power 1 plus 1. What is the meaning of that? So this minus 1 determines this part, the sign of that particular element, that particular value sign. So whenever I plus j is odd, you'll have a minus sign. The same value is even, you'll have a plus sign. If you check carefully, in the order of 3 cross 3 matrix, first one is what? 1 plus 1, so plus. 1 plus 2 is odd number, so minus. 1 plus 3 is even number, plus. Here also 2 plus 1 is odd, so minus. 2 plus 2 is even, minus. And actually alternate in nature, plus minus, plus, minus plus minus. Of course, because odd and even will be next to each other, right? Right? Okay. So you'll go with that sign. So this is going to be plus. What about is it all for determinant value? No. So actual determinant value will be written like this. So actual determinant value will be delta we write for the symbol determinant. This I'll write as it is. What is this you check? So I'll write with positive sign because it is always positive only. A11 determinant of A22, A23, A32 and A33. If you feel you know this part, you can either skip this part or you can simply watch at a higher speed, 2 times speed, 3 times speed or to 1.5 times speed. So I'm going to go to the next element, which is that A12. That is negative or positive? Negative. So right here minus A12. Now for this again, we'll remove that particular row now. We'll remove this row and this column. Check, you have left A21, A23, A31, A33, and the last element is A13. This is again positive because 1 plus 3 is 4, that's even, so positive here. For this you'll have what left? The first 4 element of second and third row. A21, A22, A31, A33. This is the value of determinant. When I teach you, in upcoming slides, this is particularly called as, what is this called as? Product of element and its cofactor. When I teach you cofactor, this is actually cofactor of the element. So basically this will become, I'll recall that there as well. This is basically given as A11 plus A12, A13, and A13. The capital A you see over here represents what? The cofactor, and small a11 represents the element. Small a is element, capital A is our cofactor. Do not worry about it, just for reference I have explained you over here. I am going to teach you once we have done the cofactor part. Again, I will recall this property. I hope this is clear. Moving on, let's find this value right now. What did I say? You can use any row, any column. Which one to use? So usually we use those row or column which has highest number of 0 present over there. Because of that presence of 0, you'll have less calculation involved, right? But in this case, there is no 0 as such. So I can take any row, any column. If we take the first one only, so determinant of A will be what? 6, that was the first row. We'll have 12 minus 1. 12 minus 1. This is minus 7. It becomes minus of minus 7. Second element is negative, right? So minus 4. Check here. Minus 4 because we're going to remove this second row now. Minus 4 minus 2 plus 8. 1 over here. For the 8, we're going to remove the first row, last column. 1 plus 6. 1 plus 6. Check. 6 into 11. This is what? Plus 7 into minus 6. And this is 8 into 7. We get 66 over here, minus 42 and plus 56. Plus 56, correct? Difference of this is how much? 4 and 2. 6 minus 2 is 4, 6 minus 4 is 2, plus 56. Plus 56, answer is going to be 60 to 80. Cross check, guys. Determinant value. This is how you find determinant. Clear? Okay. Important points to remember. First one, determinants obtained along any row or column is same. Since you have 3 rows, 3 columns, you can use any of the 6, answer will be same. For easier calculations, we shall expand the determinant across the row or column which has greater number or highest number of zeros. Because most of the things will become 0, that's why. While expanding, instead of multiplying with minus 1 power I plus j always, you can use simply plus 1 or minus 1 depending upon the I plus j value as even or odd. Determinants are not multiplied as you multiply matrices, because this is when you multiply matrices, right? Let's say we have matrix 1, 4, 6, 3 and we have 2, 0, 8, 3. Multiply row to column, na? That's not the case in case of determinant. In determinant, when you multiply this value, you have to find the value of this and then multiply. Okay? It's not multiplied as in the case of matrices. Clear? Moving on. Some properties over determinant. So if you have a matrix with the power n, if you have a square matrix with the power, basically integral power, what it means is, let's say if I have, sir, a square and I want to find determinant of that. You have to find a square, right? First, a into a you have to do and do all of that. Basically, you can simply do what? A determinant you find and then do square. This is easier. Let's calculate it in nature. Yeah. So for any matrix, if you have power involved, integral power is there, you can take the determinant first and then take the power. This also property is there. Basically, this property is what? Determinant of KB is K power n determinant of B. What is n over there? N is the order of the matrix B. Okay. If you have 2 matrices in product AB and you're supposed to find a determinant of that, you can find determinant of individual values. So A determinant times determinant B. This is easier, right? Here you are multiplying 2 matrices. It will take time. Multiply each and every element. Simply find determinant of A and B, multiply them, you will have the same answer. So A times B, or determinant of BA, or determinant of ABT, or ATB, or ATBT is same. So basically, determinant of AT is same as determinant of A, determinant of BT is same as determinant of B. Determinant may will not have any effect of transpose. The same property I wrote here as well. Clear? Some properties, but very extensively used in lot of problem solving. So of course, you will not find these properties directly in the options of the MCQs, but it's very, very useful to solve the problems for either boards or CET. Find the value of x for which determinant A vanishes. What is the meaning of that? What's the meaning of that? Determinant of A vanishes. It means determinant of A is 0. Determinant of A is 0. So we'll find determinant of A and put it equal to 0 to find the x value. We can use either third row or third column because which has same number of zeros. Here also 2, here also 2. Let's use the third row itself. We'll have plus, minus, plus, right? Yeah. So x times of, check this out, we'll have x plus 1 times x plus 4 minus, plus 2 equal to 0. Equal to 0. So now I have 2 factors over here. Let's multiply this first. I'll have x square plus 4x plus 4x plus x plus 2 equal to 0. I forgot, one more is there, plus 4 also is there, sorry. 4 into 1 is 4, right? We have 4 terms, correct. X times of x square plus 5x plus 6 is equal to 0. I have so far 2 factors. One is linear, other is quadratic. Can we factorize this? Yes. If you have 5x, I can write this as 3x and 2x, and the product is going to be what? Product is going to be what for those two? This 3x, by the way. That will be 6x square. We have the answer as same thing. First and last term multiplication. We have basically over here, you can factorize this x plus 3 and x plus 2. So you have how many values? You have total of 3 values. You have total of 3 values. Either x can be 0 from the first one, or it can be minus 2, or it can be minus 3. So 3 different values, 0, minus 2 and minus 3. 0, minus 2 and minus 3. Clear? Any doubt in this part? It's recorded, but you can ask me in the comment section. I'll reply your answer. Okay. Acha, one more thing. I forgot about that. The notes side. How will you get the notes? So one thing is, of course, if you're joining us for the first time, you can simply join our WhatsApp channel. All the classes, all the schedule, all the update will be given in the WhatsApp channel. It will basically build a community, a place where we can talk to you. We can have a conversation in the WhatsApp community. Okay. One thing is that. Other thing, bacha, for all of you. So very important. We have created something very, very, very useful for all the students studying from us on YouTube. That is called as AIO. This means all in one. Give me a minute and you'll understand why it is called all in one. Very, very useful. So if you are a CS student, what you need? You need lectures, right? Correct. You need lectures. You have that in this. What is AIO? It is a next gen learning platform created by Vedantu for your help, for your assistance, for your genuine preparation, for the students who are not able to afford, they're not able to afford financially any classes. This is something which is completely free. You're not better charging any rupee, any amount for this particular course. Okay. So all in one. First you need lectures, you have that. Then what you need? You need notes after that. You get that as well over here. Just wait for a minute. After notes, what else you need? You need to practice more questions of similar types. You get that as well over here. Assignments. You get assignments also over here. Alongside this, what else you need? Doubt solve. You have that also over here. Okay. So all in one, that's why it's called. It's something which takes care of every need of a student in our platform. AIO, all in one platform. How can you access it? So many of you are already learning from there, right? So all the YouTube lectures that you're getting, all the YouTube lectures are also available. These are all YouTube lectures are available in this learning platform. Link for this you'll find in ACE 227 free course. You'll find this in the video's description. Go and check it out. Click on that link, create your login credentials, start using and accessing the best platform for your serious preparation. Okay, let's move on. This question. Find the value of x for the given two determinant to be equal, not matrix. If it is matrix, we can compare and write x is 3. Okay, but that is going to be wrong. You'll feel that way. See, x is 3, 2x is 6 means again x is 3. Oh, maybe it is right. Correct now. Determinant, not matrix. X is 3, 2x is 6. It means that x is 3. Both of the places x is coming 3 only. So answer, if they give you the option also, let's say I give you option C as 3. Did you see there's no option like that? Not a matrix, it is a determinant. You might think, sir, what you're saying, this is very silly. But in examinations, you make silly mistakes only. You're stressed about other things. And you overlook some things. That's why be careful. Determinant, not matrix. 2x square minus 40. 18 minus plus 14, right? Correct. Check. 32 plus 40 . What is the answer? A is plus minus 6. What is the answer? A is plus minus 6. Makes sense? Any doubt over here? I hope not. Clear or not? Right? So x is not, even if I give you option like this, let's say if I change this option and write here C is 3, you will take this. I'm telling you, you might find it silly, but if I give you option like this and I make a mock test over here, few of the students will certainly tick option C as 3. You will tick that, even though it's a very basic question. So be careful. Write the value of this particular determinant. How do you solve it? Cross multiplication, nothing else is there. So A plus IB times of A minus IB minus C plus ID times of basically this is actually ID minus C. So it's going to be ulta. This will be ulta. Let me do that. ID plus C and ID minus C. Over here the formula is there. A square minus I square B square. Over here what is the formula? ID square minus C square. Open the bracket. You get A square. This will be what? Minus of minus 1 B square minus 1 D square minus C square. A square plus B square. Please check. Minus of minus becomes plus, so plus D square and plus C square. Arrange it, you will get the answer as A square, B square, C square, D square. Option is A. Both of the options A. Clear, right? Clear this one? Next, area of triangle. A very useful concept. So every paper, every year, so this chapter weightage in boards, and if you look at CET, you'll have boards around 8 marks के आसपास. In boards you have 8 marks, and in CET you have 4 marks, right? So 12 marks in total. Both are important for our KCET final rank. This concept will be there in both of the concepts. Means it will be present in your board questions also. This will be present in your CET questions also. Guaranteed. Area of triangle will come for sure in CET as well as in your. If this is not coming, means other will be easier than this. In CET I'm talking about. This is what? What is that? This is the formula for area of triangle that you have learnt in grade 10th. College geometry. Half of, remember you should write that half of x into y minus y plus x into y minus y plus x into y minus y, and then write 1 2 3 2 3 1 3 1 2. Check 1 2 3 cyclic order 1 2 3. Then we have 2 3 1 3 1 2. Same you can find using what? Determinant also. Excuse me. Determinant also. Okay, but again this will be missing 1, right? So you can write this as a delta is equals to, delta means area, is equals to half of the same result. x1 y1, the coordinates 1, x2 y2, the coordinates x3 y3, 1 1 1 1 1 1. Clear? Now one thing to remember very clearly over here, determinant value can be negative or positive both. Won't you agree? Determinant, if I am solving, I can have a negative value also as determinant. For a matrix A, determinant of A can be, both plus K also, can be minus K also. I can have both the answers. But area can never be negative. If you're finding the area of the triangle, you always have to take what? The modulus of the value which is coming in. whatever calculation you get for this part, you have to take a modulus. It is important, I'm telling you that. Yes, it is important. But why are you pointing it out? Because if you go ulta, if the area is given, you want to calculate this particular value, any missing value over here, you have to take area as plus and minus both. Because if, let's say, area of triangle ABC in a question, example I'm taking, is given to us as 6, then if you're solving this question, you will not write 6 equal to 1 by 2 this determinant. You will not write that. You write both plus and minus, because you do not know whether the answer was plus 6 from determinant or minus 6. So if area is given, means it will be taken as positive only, but we don't know whether it was minus 6 or plus 6, because area is given to us. So if the area is given to us and we want to go backward and solve any particular value or missing value of the determinant, you have to find that. Always take this as plus and minus 6, because we don't know which one was it exactly. I hope this is clear. Clear? Now, from the area of triangle only, this concept comes as condition of collinearity, or means collinear points. Look, if you have this as the triangle, A here, B here, this will have certain non-zero area. This will have certainly a non-zero value of area, correct? If I move this point A towards this line BC, there will come a point where you have this as BC, this will be point A. This will be a very small area, but not 0. Here also, delta is not 0. These both examples are the cases where the area of triangle is non-zero value. But the point A is moving towards the line BC. There will come a case where this point A will come directly on the line BC. There will come a case where the point A will come on the line BC. In that case, this area will become what? 0. So whenever the area of triangle, area of any triangle, let's say ABC also, is 0, what it actually implies? That the point ABC is actually a collinear point. It implies the point ABC is actually a collinear point. They are all lying in the same line. That's why the area is 0. This is the concept. So area we find using determinant like this. So we put determinant equal to 0. Any missing value is given. We try to find out that. That's the kind of question that is been asked. What is the missing value going to be? The missing coordinates. They can give you x1, y1, x2, y2, x3. They can give you, y3 as a constant k or lambda. They ask you the value of lambda or k. Clear or not? Makes sense? Yes, this is the determinants. Property using application in area of triangle. Okay, let's solve a question on this. I'll show you how, when the value is given as 4, I have to take it plus and minus. I told you, if area is given, I have to take both plus and minus, because we don't know whether it was minus 4 and we wrote the area as plus 4, or it was plus 4 and we wrote the area as plus 4. We don't know that, right? Okay. Find the value of k if area of triangle is given as 4. The coordinates are given as k0, 4, 0, 0, 2. Area of triangle. This is what? Half. The coordinates will be what? K0, 4, 0, 0, 2, 1, 1, 1. And this is given as what? 4. We'll take as plus minus 4. Plus minus 4. And we'll move this 2 also in this side. So we'll have 2 times of plus minus 4. Determinant, how will you find? We can find across second column, because 2 elements are already 0. So it will be minus plus minus. I hope you understand that. Please check. This is going to be A12, A22, A32. 3 plus 2 is 5. This element is having a odd position. So that's why we're going to have a minus sign. So minus 2. Check. You're going to remove this particular row and column. You'll have k minus 4. You'll have k minus 4. Correct? k minus 4. Expand it. You have minus 2k plus 8. And over here, plus minus 8. So you have two cases. When you take plus 8 as minus 2k plus 8, and you take minus 8 as minus 2k plus 8. Check. In this case, 8 and 8 cancels. You have 0 equals to minus 2k, and you have k equal to 0. Over here, you're going to bring this on this side, and this on this side, you're going to get 2k equals to 16. So k equals to 8. So you have two answers over here. K is either 0 or k is either 8. Clear? Is this clear? Let's move on. I hope this is clear, right? A simple question. Here, the most important part was this. This part, the most important part. You have to take both plus and minus. If you take only plus, you will not get two answers. Okay? Let us move on. Make sense? Yeah. So whatever concepts we are learning, we are trying to learn some or solve some questions also on those concepts. It gives us more clarity. Evaluate the determinant delta for this particular case. Looks difficult, right? Log 512 base 3, all of that. So of course, we have to use some property of log to simplify this, right? Because we don't have log 512 into log 9 with the base 4 and all of that. And also you can see they are having different bases as well. They're having different base value also. Here 3, 3, 4, 4. To find determinant of this, we'll write the numbers first. 512 is what? What is this value? 512 is, sir, actually 2 power 9. 512 is what? 2 power 9. What will be 8? I can write 8 as 2 power 3. What is 9 going to be? 9 is 3 square. Okay. And we'll write 4 also as 2 square. And there's a property I want to tell you before I start. Log of m with the base n. You have over here a and here b. Means if you have powers on the m and n both. In the base also you have power, and this value m also you have power. There is the formula for this. The law is there. A will come in front, b will come in front as coefficient. A will come in the numerator and b will come in the denominator. You have a by b log m with the base n. A by b log m with the base n. Please check. A by b log m with the base n. We'll use that. Okay. So let's write it over here. Log of 2 power 9, and here we have 3 as it is. So we'll write like this. Log of 3 and 2 square. Over here, log of 3 and 2 cube. Here we have log of 2 square and 3 square. Continue please. Delta. Coefficients will be there. We'll have 9 log 2 with the base 3. Here we have 1 by 2 log 3 with the base 2. Here we have 3 log 2 with the base 3, and here we'll have here 2 by 2 actually, right? So log of 3 with the base 2. 2 and 2 cancels. 3 by 2, 2 with the 2 and 2 cancels. Both of them will come in front. Both of these will come like this, right? Okay. Now what are you going to do? Simply cross multiply. Do that. Determinant value will be what? Multiply this 9 times of log 2 3, and here what we have? Log of 3 2. Okay. Minus 3 is a constant over here, and here it is 1 by 2. So right here 3 by 2 log 3 2 and 2 3. Log 3 2 and 2 3. Check. This is same, sir. This is same. Excuse me. This value is same. This is 2 2. This is 3 3. This is a property, by the way. What is the property? log of a with the base p and log of something, let's say x with the base a will be what? Log of x with the base b. This is same. Okay, if you apply over here, we're gonna get what? Check. This will become 9 log 3 with the base 3. This will become 9 log 3 with the base 3. 1 second. 9 log 3 with the base 3, because this is going to be gone. So x with the base b, so 3 with the base 3 minus 3 by 2 log 2 with the base 2. And log 2 with the base 2 is 1, log 3 with the base 3 is also 1. So my answer, can I solve it over here? I'm going to get 9 times of 1, delta is coming as 9 times of 1 minus 3 by 2 times of 1. 3 by 2 times of 1. That is nothing but 9 minus 3 by 2. How much is that? 18 minus 3. 15 by 2. That is 15 by 2. Option A. Option is A. Please have a look. Clear? Option is A. Next. Next concept is minors and cofactors. So what are the minors? So minors, when you have a 3 cross 3 matrix, A11, A12, A13, A21, A22, A23, A31, A32, A33. If you have this 3 cross 3 matrix and you want to find minor of each element, first of all, minor exists for each and every element. So if you have a matrix with 3 cross 3 order, it means it has 9 element count, 9 elements. You'll have 9 minus. You'll have 9 minus. Okay? 9 minus. Alright, sir, makes sense. And each minor, how do you find? Let's say I want to find minor of this particular element, A11. To remove that particular row and column, the remaining part is called as minor for the element 11. We write this as M11 equals to what? That value will be A22, A23, A32 and A33. This is the minor of the element M11. What about cofactors, sir? So we write the symbols for minor as M, I, J, and for cofactor we write it as either C, I, J, or sometimes we write it as also as A, I, J, C, I, J or A, I, J. That's the symbols we have. So difference between Mij and Aij is what? Just this. If I'm writing the cofactor Aij, it has this part, minus 1 power I plus j Mij. Depending upon the position of the element, what position, sir? Plus, minus, plus, minus, plus, minus, plus, minus, plus. Means where the row and column is present. If the sum of row and column where it is present is odd, it will be having an alternate sign, so minus sign. If it is even, will be same sign. Okay. So if Mij is positive and it was even, it will be same sign. What's the meaning of plus? If I have, let's say, if I plus j is even, will be even, and Mij is minus, let's say Mij value is negative, then will I write plus sign over here? No. If I plus j is even, then sign of Mij and Aij will be same. Listen to me very carefully. If I plus j, what is I and j? I represents the number of row, which row and which column it is. J represents the column position. So if I plus j is even, what is the meaning of this? Sign is same. Sign same means what? Mij and Aij will have same sign. If it is odd, sign changes. So basically, if it is in this position, what is the position called? A12. Then Aij, basically, if I am writing here, A12 will be minus of M12. Getting it or not? So if I have to ask you to write all the positions, can you write it? Yes, we can. A11 will be simply equal to M11. A12 will be equal to minus of M12. A13 will be equal to what? M13. That's the first row. A21 is equal to what? Minus of M21. A22 is equal to what? Simply M22. A23 is equal to what? Minus of M23. Same way, third row. A31 is equal to what? M31. A32 is equal to what? Minus M32. And A33 is equal to what? M33. So whenever this sum of the position of I and j is even, sign of cofactor and minor will be same. Can you see? They are equal actually. But if the mi plus j value is odd, then sign will be changed, reversed. This is positive, this becomes minus. If it is minus, it becomes plus. So let's not keep this understanding as if it is I plus j even, we keep the plus sign. It doesn't mean like that. I plus j is present as even, it means what? Sign will be same. For sign for aij will be same as mij. Aij means cofactor. Mij means, what is it mij? Mij means minors. Again, every matrix, every square matrix will have n elements, n minor and n cofactor. So if it has 4 elements, it will have 4 element, 4 minor, 4 cofactor. If it has 9 element, it will have 9 minor, 9 cofactor. If it has 16 or 25, it will have same number of minors and cofactor. That is not a problem. Each element has 1 minor and cofactor. Okay, this is clear. And one more thing, since I am teaching you anyway, product of element and its respective cofactors is the determinant of the given matrix. But if you take any row with any column, means if I take, let's say, first row with second column, element of first row, if I take element of first row product with, and then of course sum also, product and sum. You can see over here there is a product and sum with cofactor of second row. You'll have the answer as 0. Difference is there. If you take same rows element and cofactor both, means first row element and cofactor, second row element and cofactor, either you can take first column elements and cofactor. So if for the same row and column you have taken both element also and cofactor also, then the product and sum will give you determinant value. This is the determinant value. But if you take ulta, if you take any particular row with any column, element of any row and any column, then that will be 0. Clear? Is it clear? And yes, they have asked MCQs in boards based upon this property. Yes? Let's continue our understanding. The same thing I explained to you. In determinant of order 3 cross 3, we got 9 minors, corresponding we get 9 elements also, right? And minor of the element aij will be another determinant of the order n minus 1. Meaning of this, check here. This is the determinant only, right? Determinant of this is what? 3 cross 3 order matrix. This is coming from 3 cross 3 order matrix. But minor is what? 2 cross 2. So order of the matrix of actual matrix will be 3 if it is n, if this value beta is n equal to 3. This is what? N minus 1. That is how much? 2. So the minor matrix, the minor will be always determinant of an order n minus 1. But of course, it has to be more than 2. Clear or not? Am I making sense to all of you or not? When it was 3 cross 3 order matrix, here, determinant we are finding for this value, We are getting that minor also for 2 cross 2. So 1 is less. Here n is 3, here n is 2. Always true. It makes sense also because you're going to remove one row and one column. So order becomes, instead of 3 cross 3, it becomes 2 cross 2. Correct, na? You're going to remove row and column 1 and 1. It becomes 3 cross 3, 2. 2 cross 2 because you have reduced one number of row and one number of column. Correct? Yes. Cofactors. Already explained you. Multiply Mij with this. That's called as cofactor. So the formula is Aij, Cij equals to this. Aij equals to minus 1 power I plus j Mij. And please understand this very clearly. It is not that plus or minus. Means if I plus j is even, it will be plus. Yes, this will be plus. What it means is the sign will be same. Odd means sign will be different. Please learn it in a way you're going to apply it. Usually what happens, we think, okay, sign is same when it is I plus j. So we keep the same sign. What if it is negative, sir? We'll give it plus only. Think about it. If Mij is, sir, if I plus j is even, sir, sign is positive. That's what we learned, right? I plus j is even, sign is positive. Okay. What if Mij is negative? Will you keep it as plus Mij? Positive for what? Positive for this. This is positive or negative as per the even or odd, not the entire thing. So please learn it carefully and carefully. Okay, you will make mistakes. I have seen. I'm not telling you this by just by my own understanding. I have seen in the papers. That's why I'm telling you these explanations. I have seen these mistakes. Please do not do that. If it is positive, if it is even, means this will be same. The sign of Aij will be same as Mij. If it is minus, because that's what the property is. No, plus into minus is what? Minus only. So in plus, sign does not change. So I know I'm making more emphasis on this, but it is important. If you don't know how to find cofactors, you will end up making mistakes in determinants, in inverse, everywhere. Let's not do that. Okay. Moving on. Same thing I explained over there also. This part here as well. This is going to be determinant. This is going to be a 0 value. Here you check. This is all determinant. If you take, this is what? Check here. This is the row 1. This is the row 2. This is the row 3. I can do the same for column also. I can do the same for even column also. I can do. You can write this for column also. Column wise also you can write. Right? In that case, what you're going to have? A11, A11, A21, A21. Right? You'll have like that. You can add these also. If you add A11, A11, A21, A21, A31, A31, you're going to get what? Still delta only. Okay? But if you take sum of the product of elements of any row with or column with cofactor of any other row or column, that becomes 0. So see here, this is element of first row and this is cofactor of second row. This is basically Aij into Aij. This is from row 1, this is from row 2. Multiplying row 1 element to cofactor of row 2. That's why it is 0. See, A21, A22, A23 is the cofactor of second row. This is first row's element. Product will be 0. And yes, they have asked these questions in the MCQs, especially in boards, so they keep asking. Okay. Find the minor and cofactor of all the elements. This is simple, right? We'll have what? M11, M12, M21, M22. Check. M11 will be what? Over here. We'll have this value as D, positive only because it is even. Over here, actually this is always the same, no problem. There's no sign over here. This will be B. Okay, whatever. For M11, you're going to have to remove this and this, so you'll have D. For that, you'll have B. For this, you'll have C. For this, you'll have A. Correct, right? What about A11, A12, A21 and A22? A21 and A22. Check. I wanted to say same as M11 if it is positive. Same. Negative, so minus B. Also negative because it is odd, so minus C. Sign is different. Here also same. Please check. Minor and cofactors. Minor and cofactors. Clear, right? So far so good? Correct. Adjoint of a square matrix now. Adjoint of a square matrix. How does it work? So we write this as adjoint of the matrix A as given by what? Cofactor matrix transpose. What's the meaning of that? It means you're going to write the matrix Aij transpose. Adjoint of matrix A means that Aij transpose. If it's confusing, let's write Cij also. So write the matrix where each element will be what? Cofactor of the positions. Okay, A11, A12 like that. Okay, this is the element form. This is all what? What is this? This is the cofactor matrix. This is called as cofactor matrix. A11, A12, A13. And what is this? Can you see that? If I call this to be, let's say, matrix B, then this is nothing but B transpose. Let me verify for you. A11, A12, A13. A11, A12, A13. This is what? A row. Check here. A11, A12, A13. What is this? A column. So the row here becomes column. Check next one. A21, A22, A23. Again, A21, A22, A23. A21, A22, A23. Again, column. Check the last one. A31, A32, A33. A31, A32, A33. This is again what? Column. So what we've done over here. If this is my cofactor matrix, I'm taking it as matrix B. This is nothing but B transpose. So adjoint of A is given by cofactor matrix transpose. How to find cofactors? We have learned that. Find the minors. For even position, sign remains same. For odd position, sign will change from the minor, just opposite of the minor sign. Makes sense. Moving on. Adjoint of a 2 cross 2 matrix is very simple. What is that? Simply, if you have this matrix A, B, C, D, right? This is my, let's say, matrix A. This is the matrix A. Then over here, this is going to be what? Interchanged. This will be interchanged. And this, the other one, will be only sign change. For the other element, you're going to change the sign. For this, you're going to interchange it. So let's look at adjoint now. So adjoint of A, as per this rule, it will become what? D here, A here, minus B, minus C. Check this out. D minus B minus C A. D minus B minus C A. This is your adjoint of A. Can you see the level of, in depth we are going? We're covering up every single thing. Okay. That's why this notes will be very important for you. These questions will be very important for you because I have done that segregation, the segregation basically. First concept, then question, again next concept, then question, and like that. And at the last, I'm going to solve some more problems from the KCET PYQs also. So this session will be a right mix where you can revise quickly in a small session of few hours. You can revise your concepts, your board's understanding, your CET questions style. All of this will be revised in this session itself. So very important class. And please do not forget to refer this channel, Diksha Karnataka, to all of your friends, to all of your juniors, whoever is learning and studying, because we are doing for first PUC also. I'm telling you, they will thank you actually if you refer this session to them. Okay, so refer your friends, whoever is in second PUC, first PUC, we are doing preparation, we are doing support, we are providing support in their education, for boards as well as for CET. So help them, solve these questions with us, help them learn with us. Okay, share the sessions, share this video with all of your friends who needs it actually. Okay. Next is a concept which is very, very useful to build for the next level, which is called as inverse, and that is, what is it? Singular and non-singular matrices. Singular and non-singular matrices. How does it work? Very simple, sir. Singular matrices are those matrices which determinant value comes out as 0. Means for a given square matrix A, check here, determinant you find 4 4s are 16 minus 16 into 1, 0. So the matrix A is actually singular in nature. Determinant of A is 0. This is singular matrix. What is a non-singular? Just opposite. Whenever determinant value is not 0, in this case 5 into 1, 3 into 2, that is coming as minus 1, not 0. Negative, yes. Determinant can be negative, positive, anything. It can be 0 also. But if it is 0, it will be called as singular matrix. And if it is non-zero, it is called as non-singular matrix. Does it make sense? Yes. Achha, I hope you have all joined the WhatsApp channel, guys. I did inform you all to please join the WhatsApp channel. It's very, very important. Okay, because all the updates, all the information regarding your classes, your AIO platform, everything will be given in the WhatsApp channel only. The link is provided in the description. Go and check it out and join right away. All right. Okay, this is clear. Moving on. Some important theorems. And yes, these are directly asked even in KCET also. This is the KCET PYQ. Trust me. This is a KCET PYQ. I remember the question also. They said, choose the incorrect statement. And in the 4 options given to you, one of them was this as well. There were 3 other options. This was correct one actually. Okay. In the wrong options, they gave the same property without determinant of A. Without determinant of A. So answer was that option basically. Check the questions. PYQs. I'll see if I've taken the same question over here also or not. But yes, this question was there. The property is A adjoint A, means when you multiply matrix A with its own adjoint, you either multiply adjoint to A or adjoint A to A. The result is always determinant of A times of IN. Determinant of A times of IN. Yes, determinant of A times of IN. Got it? Got it? Yeah. Okay, sir. That's the first theorem. Theorem number 2. Again, this is for square matrix of the order 10. Okay, means they have order n, so that's why you'll have a IN over here. The same order identity matrix will come. Theorem number 2. If you have A and B non-singular matrices, A and B are non-singular, means determinant of A is not 0, determinant of B also is not 0. That's the meaning of non-singular matrix. Okay. Then, and of course they must be of the same order. Then AB and BA are also non-singular. It means AB will also be non-zero and BA will also be non-zero. Can you recall why? I'll tell you. Remember, I wrote this few slides back. AB is equal to A into B, and this is also equals to BA. So if A is not 0 and B is also not 0, they are both non-zero values, and you multiply them, what will happen? This will also be non-zero. This will also be non-zero, which means what? AB will also be non-zero and BA will also be non-zero. This is called as what? Non-singular matrix. Means the matrix AB, yes, the product of two matrices is also a matrix. AB will be non-singular matrix and BA will also be a non-singular matrix. Does it make sense? Does this theorem make sense or not? Please check. If A and B are non-singular, then AB and BA are also non-singular matrix of the same order. Come on. Theorem number 3. The determinant of the product of matrices is equal to the same thing I wrote right now. AB is equal to determinant of A into determinant of B. Okay. So this property, very, very highly useful, and yes, direct KCET PYQs, direct KCET plus your board's PYQ, have been asked on this. Direct. You can expect a question on this here as well, on this property. One of the favorite property of your boards and seed, both. Determinant of adjoint of A is determinant of A power n minus 1. Depending upon the if you have, let's say, adjoint of another adjoint of another adjoint, let's say only 3 is there. Let me write this as only 2. Okay, this is going to be determinant of a power n minus 1, and count the number of adjoints. We have 1 and 2. You'll have here, if you have beta over here, adjoint times of adjoint, how many times? N times. If you have n times, okay, or let me write it better, some other variable. Yeah, let's say you have 3 times. P is not going to be that close. K times, okay, this is better, of A. If they are saying adjoint of adjoint of adjoint of adjoint of adjoint of adjoint of A, how many times adjoint? Adjoint is coming K times, then answer of this will become determinant of A power n minus 1 power K. What is determinant of that you can find, right? N represents order of the determinant of the matrix A, sorry. N represents order of the matrix and K is the number of adjoint. Minor of an element of a determinant of the order n more than 1 is determinant of order what? Minors of an element. Minor of an element, if you are writing, determinant of order will be 1 less, right? So if it is n over here, then the order of the determinant of the minor that we are writing, right? Remember, when we write the minor Mij, we write this as a determinant only, right? So if it is coming from a 3 cross 3 matrix, if the matrix A was a 3 cross 3 matrix, this will become what? A 2 cross 2 matrix, because we're going to eliminate 1 row and 1 column. So 3 becomes 2, and again the row also becomes, row and column both becomes 3 minus 1, 3 minus 1, so 2 and 2. Makes sense, because we remove 1 row and 1 column, right? So we have n minus 1. Option C is correct. Simple, right? Let's move on. Next question. Adjoint of A is what? Transpose of minors, transpose of cofactors, or transpose of determinant? Very simple answer. Transpose of cofactor, if you want to be specific, matrix, because adjoint of A is nothing but adjoint of A is a matrix. Okay, so if you're writing adjoint of A, what is this? It is, if I want to write either in the form of Cij, so I'll write Cij transpose, where Cij represents what? Cofactor matrix. Cofactor matrix. Makes sense? Cij is cofactor matrix. Adjoint of A is the cofactor matrix taken as transpose. Usually we write it as Aij also, but just to create a differentiation, I have done it over here. Okay, transpose of cofactors, correct. Next, the given matrix of order 3 cross 3 is a singular matrix. Is a singular matrix. Means what? Determinant value will be 0. Then find the missing value of x. Try. You also try. Pause the video right here and try to solve from your side. Let's see. Of course, I have to trust you on the honesty. Try to solve it and give me the answer in the comment section. Let us check how many of you got the same answer and how faster you took to solve this question. Okay, expansion is there. Any other clue we have, sir? Actually, no. We don't have zeros or anything like that. I have to do the actual expansion only. So let's try with the first row itself. So we'll have 2 plus x. You know that very well. The determinant of A must be what? Equal to 0. So that's why 2 plus x times of, we'll have 5 minus 2. We'll have 5 minus 2. Next, with minus 3, we're going to remove second column in the first row. So minus 5 minus 2x. Minus 5 and minus 2x. And the last one, plus 4. We have 1 plus x. 1 plus x must be equal to 0. Check this out. This is 1 and this is minus x. When you subtract, it becomes plus x. This value is what? 3. So becomes 6 plus 3x. Over here will become what? Plus 15 plus 6x. Then we have plus 4 plus 4x. Take the sum. 6 plus 4 is 10 plus 3 is 13x. We have 13x. 15 plus 6 is 21. 21 plus 4, 25. I think we have an answer like that now. Minus 25 by 3. 13, sorry. Minus 25 by 13. My bad, not 3. Check here. 13x equals to minus 25. So x is minus 25 by 13. Yeah. So yes, this kind of question will not be asked in CET, but they can be certainly asked in the MCQ side of boards. Okay, if you have a, let's say we are preparing now for what? Our midterms. So in the midterms, you can expect questions like this from the chapter Determinant. Because this is actually from your question bank only. This is the important question. I've seen this question either in the question bank or in the PYQs of boards, not of CET, of course. Okay. Moving on. I hope this is clear, right? This question is clear now. No doubt over here. No chance of this doubt. Did you get the same answer, all of you? You got the same answer? Good. Let us move on. Next is what? Determinant of adjoint of A. They are asking us determinant of adjoint of A. Yes, you are recalling the right property. Determinant of A power n minus 1 to the power number of times adjoint is coming. Determinant of A power n minus 1, and is the number of, basically the order given in the square matrix, which is of course over here 3. And number of adjoint that we have, same power will come for n minus 1. In this case it is 1. So we don't have to write any power because power 1 is same, right? So we write this as determinant of A. 3 minus 1 is what? 2. N is 3, right? Check now. The order is 3 cross 3. The order is 3 cross 3. So n is 3. Any problem? Now, yes, this is very simple to find, by the way, right now. What is the determinant of A? That's going to be A cube. Answer becomes A cube the square, and it becomes A power 6. That's option C. Acha, I want to tell you one very important thing. So there are 3 cases. Case 1, when it is a diagonal matrix, means it can be scalar or whatever it is, okay? A diagonal matrix. This is also a diagonal matrix only, no? Scalar matrix actually. Or it is a lower triangular matrix, okay? Or it is a upper triangular matrix. What does it mean? It means lower triangular matrix, and this is what? Upper triangular matrix. Whenever you have these 3 cases, whenever you have these 3 cases of the matrices given, the determinant value is what? Is always product of diagonal elements. Always remember this. If you have given in the question as diagonal matrix, of course it is logical as well, right? Because if you go with, let's say, row number 1 or column number 1, the first element is A, every other element is 0. That becomes simply 0 only, right? So if you have this case where you have diagonal matrix given, you have lower triangular matrix, you have upper triangular matrix, do not waste your time finding determinant. Simply multiply the elements given over here for what? For the diagonal. So multiply the basically product of the diagonal element will be the determinant of A. Okay, can I move on? Yes. Properties of adjoint and inverse of a square matrix. Of course, what is inverse? We'll look into that. What is inverse of a matrix? We'll look into that. That will come. Here it is. Let's learn the properties of adjoint right now. The property, since we are learning, that's why I put it all together itself. Okay. These are important, very useful in the question solving for both the examination. If you are taking transpose on the inverse, you can simply take inverse on the transpose, the result is same. So for any invertible matrix, if A is said to be invertible, what it means? It means inverse exists. What it means? that it is a non-singular matrix, right? So for A as an invertible matrix, transpose of A inverse is same as inverse of the transpose of A. Transpose of A inverse is same as inverse of the transpose of A. That's the property number 1. Moving on the adjoint side. Adjoint of AB is adjoint B times of adjoint of A, provided A and B are both non-singular matrix. They are both non-singular matrix. Okay, of course of the same order. So adjoint of AB will be given by adjoint B times of adjoint A. Property number 3. If A is an invertible matrix, then adjoint of A transpose is same as adjoint of A transpose. Means adjoint A then transpose is same as adjoint of the transpose of the A. Next, property number 4. This is what I taught you, right? And so this is the other one. I told you there was a property where it was having adjoint of A. Means the series was there. In that case, what happens? This is given by determinant of A times of n minus 2A. The other one was what? In the other case, it was determinant of A times of I. Right? Okay. Right? Remember over here, I think I wrote all the properties. Here, right? Yeah. A adjoint A and adjoint A is determinant of A I n, because this is the PYQ of CET, by the way. Okay. So this is the PYQ of CET. What is the other case? Adjoint of adjoint A. I'll repeat. This is A into adjoint A. This is product of two matrices. A into adjoint A. Adjoint A into A is a determinant of A times of I. But the case that I was looking at, it is adjoint of adjoint A. Here. Adjoint of adjoint A is nothing but determinant of A power n minus 2 times of A. Okay. From here only we get the other property. Which one? This property actually. Look at this. If you have 3 adjoints, okay. So determinant of adjoint of adjoint of adjoint of A, determinant of adjoint of adjoint of adjoint of A is determinant of A power n minus 1 as per the order of the matrix, and 3 because of the number of adjoints present. I already explained you this, I remember, right? If A is a non-singular matrix, then determinant of A inverse is equal to, what is it? Determinant power minus 1, which will become, will this be inverse? This is basically reciprocal form, and this is the property. We use it. They have asked this as MCQs in the boards. Determinant of A inverse is nothing but 1 by determinant of A, because this is going to be a reciprocal, because determinant value is a scalar fixed value. If you take power minus 1 means it becomes simply reciprocal form of powers, indices, okay, indices. Property number 7. If if the product of two non-zero square matrix is zero matrix, then both of them must be singular matrix. What it means? Matrix A, not determinant, matrix A is not 0. Matrix B is also not 0 matrix. They are non-zero square matrices. But AB is coming as 0. The product of two non-zero square matrices is the 0 matrix. This is, so far it is basically, what is it? So far it is going to be only matrix. But the last statement is going to saying that then both must be singular. What it means is determinant of A should be 0 and determinant of B should be 0. There is a difference. In the first two statement you are looking at matrices. Non-zero matrix, and the product is coming as 0 matrix. Then the determinant of A and B will be 0, because that is going to be a singular matrix. Adjoint of KA is nothing but, K is a constant, K power n minus 1 times of adjoint of A. K is a real number. Again, A must be a non-singular matrix, right? Time to look at inverse and how to find inverse of a matrix. So remember, when we were learning in matrices properties, I told you AB and BA are not always true in the case of matrix multiplication. What property is this? If you remember, this is the property of commutative. Right? In this property, We have associative, commutative and distributive property, right? So in this property, what happens is AB equals to BA. I told you in the case of matrix multiplication, properties of matrix multiplication, this is not true. And I told you there itself as well, it is only true when A and B are inverse of each other. Whenever AB equals to BA equals to I, then only we can say this is possible, because A and B will be inverse of each other. A and B will be inverse of each other. Such matrix B is called as inverse of the matrix A and is determined and denoted as A inverse. Okay, as A inverse. If you continue like this and take transpose, basically take the value as determinant, AB becomes equal to determinant of I, you get determinant of A and B equals to 1, and then you start, basically if this value is non-zero value, correct now, non-zero value, then only we can find the inverse. Okay, so if this condition is true, means if A is invertible, then determinant of A must be non-zero. Can you tell me why? Think about it. If beta determinant of A times of determinant of B is equal to 1, how are we getting this value? How are we getting this value 1? Any idea? Yes, from here, check. If AB was equal to I, right, and you apply determinant on the equation, determinant of AB is equal to determinant of I. This value is how much? 1. We know that very well. Determinant of identity matrix is what? 1. And for this, we'll have the property as, we can separate the determinants A and B, A and B. So the product over here is equal to what? 1, right? So if product of two matrices is equal to, or two values equal to 1, it means they are both non-zero. A is not 0, B is not 0. Because even one of them is 0 means the whole thing becomes 0. Since the product of A and B is not equal to 0, it means what? A must be a non-zero value. So if this property is true, it means A and B are invertible, and for A to be invertible, A has to be, determinant of A has to be not equal to 0. It means it has to be non-singular matrix. So we have three important things to remember over here. What is the first thing? If AB equals to BA equals to I, then next is what? Then what happens? A is invertible and B equals to A inverse, and third one is determinant of A is not equal to 0. That implies basically what it means, A is non-singular. A is non-singular. Getting it or not? AB equal to BA equals to I, that means A is invertible. That is the case where A is invertible, and if it is invertible means we write B as A inverse, and determinant of A must be non-zero because we just saw it right now, right, using this condition. Check. Clear, right, what is inverse and how does it work? Next is finding the formula for inverse. This is the formula, right? Adjoint A by A. So if you're going to use this property, we just learned it, right? A adjoint A equals to adjoint A times A equals to determinant of AI. Take this two case or any two case, take this two comparison together. Okay, this two. Or basically you divide by determinant in this case. You're going to have what? A times of 1 by determinant of A adjoint A. Okay. And if you take inverse on every side, you're going to have what over here? If you multiply inverse, let's say if I, in this only, if I multiply right inverse to left inverse, I'll take this condition. Let's say I'll take this condition. What I have? A 1 by determinant of A adjoint of A. I can take the other one also, okay? I can take this two combination also. In the second combination, I'm going to use what? I'm going to use the right inverse. Over here, I'm using the left inverse. Left multiplication, sorry. Over here, I'm going to use the right multiplication. Here, I'm going to use the left multiplication. What are you talking about, sir? Basically, I'm telling you that multiply A inverse on both of them from left hand side. Check it out. It will become A inverse A. That is how much? I. This is as it is 1 by determinant of A. Sorry. Adjoint of A. A inverse I is nothing but A inverse. You don't write I actually. And you get the answer as what? You don't have to write I. A inverse equals to adjoint of A upon determinant of A. That's how we get the result. So once we prove that determinant of A is non-zero, right? This is the converse. If A is a non-singular matrix, a non-zero value, then in the property we can divide it by determinant A, and we can use the left multiplication or right multiplication rule based upon our convenience, our understanding. We end up with inverse of A has a formula adjoint A upon determinant of A. I hope this is clear. Clear, right? Makes sense. Can we move on? Yes. Properties of inverse of matrix. Properties of inverse of matrix. Inverse of A to inverse is back to the matrix A itself. If you are taking product of matrix and taking inverse, over here also reversal law holds true. Reversal law holds true, means B will come first, then you'll write A inverse. K A inverse will be simply K as a constant. K will be treated as a constant, and if you have constant power minus 1, it becomes simply reciprocal. So 1 by K A inverse, provided K is a non-zero value, because otherwise it will become undefined. If K is 0, it will become undefined, right? A inverse, A times of A inverse is what? Simply A inverse times A or equals to I. If you multiply the matrix to itself, the inverse of itself, the result is what? Identity matrix. I used it over here. Please check. A inverse A is I. Okay. Only square matrices have adjoint or inverse. This property is not true for rectangular matrices. Next, if A, B, C are invertible matrices, then same. This is what? Again, same reversal law. ABC product inverse is same as C inverse, B inverse, A inverse. C comes back in the front, A goes in the last. C is over here, A inverse over there, B stays in the middle. Okay. So properties of inverse of matrix. Any doubt you are having, please let me know in the comment section. It's very important to understand this very clearly. Getting my point? How important is this? I'm telling you, these properties will be directly applicable either in the questions of MCQs boards, or you'll have applications of these in the CET. I'll show you the questions. Today in this class, I'll discuss some of the CET problems, some of the board style questions also. You will see the applications of the properties over there. Moving on. Working rules to find the inverse of matrix by using formula method. Basically, what is the formula we have learned, no? What formula was that? Right here we have this formula to find the inverse. This is there, this is required to find the inverse of matrix. Sometimes when we go ahead and solve the linear equations, we also use this method, right? Let A be the given matrix, then first find determinant of A. Okay, means for any given matrix, first find determinant of A and check whether that value is coming equal to 0 or not. Yes, if determinant of A is coming as 0, means it will be a singular matrix, and for that inverse does not exist. We just proved it right now. We proved it over here. Here, for inverse to exist, for A to be invertible, I should have determinant of A as non-zero. Non-zero. This was the condition. If it is invertible, it must be non-singular. So we have to check whether A is a zero value, like determinant of A is 0 or non-zero. So if determinant of A is 0, then inverse does not exist. Inverse will not exist. Next is what? If A is a non-singular matrix, it means determinant of A is non-zero, then yes, inverse will exist. And for that we have to find the adjoint. Okay, basically we have to find the cofactor matrix, take its transpose. This is basically called as finding adjoint of A. Determinant we already found. We take the formula A inverse as adjoint A by determinant of A, use that to get the inverse of the matrix A. Clear? The matrix is given over here. This is a very beautiful question. This is from, I think this is a CET problem. This is a CET problem which uses properties. You will see this is using properties. Okay. All right. Yes. Try this right now. Please try to solve this right now. Please try to solve this question right now. Please try to solve this question right now in the class. So you all solve this, okay? But I want to solve one more question. You know, when I was looking at this, I remembered one question. I want to solve that first. So I forgot to put it over here. That is inverse. The question is inverse of a matrix if it exists is always unique. So I forgot this question to put over here, but it is a very good question for board style problem. Please read the problem again. Inverse of the matrix if it exists is always unique. Is always unique. Okay, let's try to understand this now. It says that if you have a matrix, let's say A, okay, and for a matrix A, if it is given as non-zero, that's why the word is if it exists. For inverse to exist, I must have the matrix as a non-singular matrix. The determinant of A is not equal to 0. Not equal to 0. Great, makes sense, super. So for inverse, if it exists right now, it must be unique. It means we cannot have two different answers for the same matrix inverse. Unique means what? For the same matrix A, we cannot have two different inverse. We have to prove that. Okay, but we don't know. We have to see. Okay, so what we're gonna assume now, that the matrix. So let us assume matrix A has two inverse. What is that? Matrix P and matrix C. I don't know that, so I've started with the assumption. Okay, I've started with the assumption that matrix A has two inverse, which is matrix B and C. So how can you do that? My assumption can be anything, right? I can assume anything. This is my assumption. So how do we get the answer from here, sir? Don't worry. Let me tell you that first. So the question statement is inverse if it exists, it must be unique in nature. I have taken a matrix A, which is a non-singular matrix, means inverse exists, and I've taken two different inverse of that. Two different inverse of that. Let's understand the case. When B is inverse of A, when B is inverse of A, what it means? Remember, definition of inverse. Sir, AB will be equal to BA will be equal to I. Do you all remember this? I hope you all remember this. That's the property of inverse. If B is inverse of A, then AB must be equal to BA must be equal to I. Correct. Second case, when C is inverse of A. In this case, you'll have AC equals to CA equals to I. AC equals to CA equals to I. This also makes sense, right? Both of these make sense. Definition is there. I have not done anything but writing the definition. Now, we'll assume a product of matrix which is BAC. Why BAC only, sir? Because it has product with A to B and C to A as well. I have product of all the three together. Sir, why not take ABC? Why not take ABC? Because in this case, AB is there, but there is no CA. You have BC. Check in the relations you have. Do you have BC anywhere? No. So I have the condition for AB, AC, CA, AB means I have B multiplied to A and C multiplied to A. So if I take the product of three matrices as ABC, I will not achieve that. So what I'm trying to do over here is I'm trying to find the product condition for all three together and see. I'll show you that they are actually same value. Let me show you. The first condition BAC. Let me change AC to I. So I'll take BAC, in this I'll take AC to I. AC to I. What I'm getting over here? B into I. How much is that? B. Correct or not? This is my equation number 1. Equation number 1. I've taken what? AC as I. So BAC becomes B into I, and B into I is the matrix B itself. I'll take this again. The same thing I'll take again over here. BAC. In this case, BAC, I'll take this time BA together and write as C. What is the value of BA? BA is also I. Write that. I into C. How much is that? C. Equation number 2. So in one case, I'm getting BAC equals to the matrix B, and second case, I'm getting BAC equal to the matrix C. What it means? It means from equation 1 and 2, what do we have? We have actually BAC equal to B, and that is also equal to C as well, which means what? B and C are same. B and C are same. So actually in the question that I assumed that B and C are two different inverse. Let us assume A has two different inverse. Two different inverse B and C is not possible actually, because even when I took two different inverse and applied the condition for inverse of the matrices, I am ending up with what? That B and C are equal, because BAC is product of three matrices. The same value is coming equal to matrix B as well as C. It means if BAC is equals to B and BAC is equals to C as well, so B and C must be equal. So what we assumed in the beginning as different, that is wrong. That is wrong. What happens in this case? Hence A inverse is unique. Hence A inverse is unique. Hence A inverse is unique. I hope this is clear. Since B and C are same, it means they will not have different value, they will have the same value. So A inverse is unique in nature. It's a very good question, guys. It is a very, very, very good question. Okay? Yes. Achha, take a look one more time. Done? Any doubt you have in any of the steps, put that in the comment section. I'll help you out. Okay? Great. Next, if the matrices A is given over here, matrix is given, B is given as adjoint of A. B is adjoint of A. Means I need to find determinant first of all. Let's do that. Let's do that. Determinant of A we'll find out. So we'll have over here 1 times of 9 plus 4. Correct now? 9 plus 4. We have minus 1. We have 3 minus 4. Check. 3 minus 4. 3 here, minus 4 here. We have plus 2. We have minus 1, minus 3. I hope you have the answer. Okay. Minus 1, minus 3. That's minus 4. Check this out. Minus 1 with 2, I have minus 1, minus 3. Correct, right? Minus 1, minus 3, it's minus 4. Simplify. I'm getting 13. It's going to be minus 1. So plus 1, and this is minus 8. I'm getting the answer as 14 minus 8 is 6. Determinant of A is coming as 6. Determinant of A is coming as 6. Okay. It says find the value of, check this out. Let's see what they're asking us. Adjoint of P, determinant upon determinant of C. Determinant of C. Adjoint of B is what? P is adjoint A. So replace B by adjoint A. Determinant of adjoint A. That's it. Replace B by adjoint A. Determinant of adjoint A. Can you see use the properties? And what is C? C is determinant of 3A. From here. Can you see the properties? Yes. Adjoint of A is a determinant of A power n minus 1 power 2. There are two adjoints, so power 2. And this is nothing but 3 power n determinant of A. 3 is the constant, so 3 power n determinant of A. N is what? N is 3. Use the values over here. Determinant of A is coming as 6. So 6 power 2 power 2. N minus 1 is 2, 2 power 2. And over here, 3 power 3 into 6, because determinant of A is 6. Continue. Getting this value as 6 power 4 upon 3 cube, right? Yeah. And then we have again 6 over here. If you check, this will cancel this with 3. Am I right? Let me continue. Over here. So my value is coming as 6 is nothing but, so I'm getting here 6. 6 I'll write it as 2 into 3, the cube, upon 3 cube. Am I right or not? 2 into 3 cube is 6 cube basically, and this is 3 cube. I have, this will get cancelled. 3 cube is cancelled. What is the answer left? Eight is the answer. Option is C. Again, I have done all the steps so that you are not confused, but you can simply ignore multiple steps, okay, to save time. You can solve these questions in your mind as well. You can solve this question on the mind as well. Determinant, once you have determinant value, and you know the formula, you can solve this in your mind. Rough page, one straight step. This is a simple calculation question. This is a very simple calculation problem. Moving on. This is clear? Moving on. Okay. See how the properties helps us. And without them, we can't solve it. Okay. Find determinant of B for 2 cross 2 matrix. D says that this is given. I want to find determinant of B. Let me assume this as X and this as Y. So basically, they have given us XB equals to Y. They have given us XB equals to Y. You want to find B, right? So let's find here X inverse XB and X inverse Y. What is this? Taking left product of X inverse on the equation of matrix. This becomes I into B is what? Simply B. So B equals to X inverse times Y. To find the value of B, I have to find the X inverse first. So find X inverse. X inverse will be what? Adjoint. Let's find adjoint first. How do you find adjoint of X? Interchange this value, so you'll have 7 over here, 2 over here, and sign change. This will become -5 and +3. I taught you this. Interchange the diagonal and sign change of other two elements. Divide by the determinant. 14 plus 15 plus 29. है ना? 14 and this is 15. So plus 29 we have over here. Let's check. Matrix is B, 1 by 29, and this value is 7 minus 5, 3 and 2. This is going to be, what is Y? Y is, sir, 17 minus 1, 47 and minus 13. Cross check. 7 17s are what? 7 17s are, because we have to multiply row 2 column, okay, yes. So 20 times of 7 is 140, right? Minus, what is it? 21. So 119. Am I correct? Right? This is what it is. And this is going to be what? Minus 47 into 5. So 250 will have over here. So what? 255 had over here 50. So, okay, let me just cross check. We don't have to do that. Okay. Let's not waste time on this. Okay. So let me just multiply this over. Okay, we get 9. Yeah, correct. Then we get this as minus only, yes, 5. And then 20, and then we have 23, correct, 235. Okay, yeah, 235. This is going to be what? This value is going to be again subtracted. You'll have 1 by 29, and then this value will become what? You'll have over here 15 minus 9 is going to be 6, 12. So 2 minus 1 is 1. Okay, then again we have 116. Check this out. 30 into 4 is 120. This will become 4 actually. This element will become what? 4. So you can just simplify this. Okay. So you'll have over here, again you try, minus 7, 65. Correct, right? Minus 7, 65. That's how much? 58. 58. Okay. Correct. Next you go 51, and we have 51 plus, we have 94, right? 94. And the last one, minus 3, minus 26. Minus 3, minus 26. So minus, is it right? Minus 3 and minus 26. That's, yeah, minus 29. Correct. That's correct. So we have the values over here as 58. Over here we have 5 and 145, right? Correct. And this is minus 29. So if you divide everything, you're going to get this value as what? This value becomes 4, 2, 5, I guess. Yeah, 5. This is minus 1. This is your value for matrix B. Determinant you can find. I want you to solve and give me the answer for this value in the comment section. I am waiting from all of you. Determinant of B is what? Find this value. Comment section. Okay. Matrix is here. Determinant you find. Can I move on? Let's move on. Next is very important condition. Very favorite of your CET. Boards also they ask. But this is a basically a almost guaranteed question in CET. Consistent and inconsistent system of equations. So it starts like this. Consistent form. It has two conditions. One of them is unique solution, and the other one is what? Infinite solution. Unique and infinite solution. These are the two conditions given over here for consistent. For consistent. Next. The second one, which is inconsistent. For inconsistent, we have again what? For this case, we have no solution. Correct. For this case, we have no solution. This is only one. So no solution. Clear? Now we'll have to understand each of the categories one by one. Okay. So we'll go to that later. Let's understand each of the category one by one. Means we'll have three categories over here. Actually, we'll have three categories. This is 1. Let's call this to be 2. Let's call this to be 3. Call this to be 3. Okay. So let me take it over here only. If you have equation format as Ax equals to b, that's how you write any equation in the matrix form, right? Have a look at this as well. This is what? This is a coefficient matrix. This is called as matrix A. The variable matrix is x, and this is equals to the constant matrix, which is b. We have Ax equals to b. If this condition is given to us, this condition is given to us or known to us. Ax equals to b is known to us. See, I have written over here. Then what is my nature of solution for the given simultaneous equation? We have three ways to find out. We'll learn all of them. The first consistent of is what? Solution is what? Unique. And this is very simple, guys. For this condition, if you are able to find out determinant of A is not 0, that is it. Nothing else is over here. If you can find out determinant of A is non-zero, means non-singular matrix. What it means? Non-singular matrix. What will happen? Then of course A inverse will exist. And we know that inverse of A is always unique, है ना? Right? If this is non-zero, means inverse will exist, and inverse is always unique in nature. So if you are finding x, you'll have what? A inverse times of b, right? If A inverse is unique, then product of A inverse and b will also be unique. Think about it. If to find the matrix x, the variable matrix, I have to do A inverse times of b. what we're doing, left multiplication to the equation of given over here with A inverse on both sides, right? So A inverse A becomes I, that is going to be simply X left, and this is A inverse B. Agreed, na? So X is A inverse B. That is understandable that from where we are getting that. So if A inverse, to find X, we need to find A inverse into B. B is given in the question. B is a constant matrix given in the question. A inverse, if we find out, if it is non-zero matrix, which is a non-singular, which means A inverse exists, and we know, we just proved it right now, that A inverse is unique in nature, always unique. So if A inverse is unique, A inverse B will also be unique. Product of two unique matrices is always unique. Hence, the answer will be what? Unique solution. The value of X you want to get, the variable matrix, let's say variable is XYZ or XY or whatever is the variable, that will have a unique solution. So the nature of the solution becomes unique when you have determinant of A as non-zero value. Determinant of A as non-zero value. Tell me how many of you understood this? Tell me how many of you understood this? And second one is again the same case of consistent. As I mentioned, consistent has two different forms, unique as well as infinite. This is going to be the infinite solution wala case. Infinite solution wala case. How does it work? It starts only from the first thing is determinant of A is 0. Determinant of A is 0. And you also have to find out adjoint of A times, this is a matrix, times the matrix B is also 0. So if determinant of A is 0 and this is AND condition, and adjoint of A times B is 0, then the equation will have infinite solution. What it means is, it means if this is my first line of first given equation, the other line will overlap it up. The other line will overlap. The lines are overlapping in nature. Coincident line. Coincident line. Lines are overlapping each other, means it has multiple points of intersection, hence it is infinite solution. Clear? The third one is no solution. This is the inconsistent form. The inconsistent form. Over here, again, you'll have this as it is. Determinant of A as 0 and adjoint of A times of the matrix P is non-zero. This is going to be what? Usually we write this as parallel lines. Means lines are parallel. It will never meet. It will never meet. So it will be no solution. And what about this one? This will be intersecting lines. This will be intersecting lines. So answer is unique solution. Answer is unique solution for this case. I hope it makes sense. So from now onwards, please remember this and your troubles will be sorted. Whether it is a CET problem or board's problem, there are two forms, consistent, inconsistent. Inconsistent, we have two different forms, unique and infinite. In inconsistent, we have only one, which is no solution, and the conditions are very much clear. Figures are clear. Yes or no? Please have a look. That's why I kept saying it. This is going to be a very, very, very important note. Even if you feel that you have prepared determinant for your FAs, or you prepared, it's an easy chapter. But when you revise with me in this session, no, I'll take care of all the concepts. I'll take care of the problem solving, revision of all the concepts, application of concept in the questions will be taken care of for both your second PUC board as well as your KCET. So if you are watching me right now, please share this session with all of your friends, all of your classmates who can benefit from this session. Okay, let them know about our channel Diksha Karnataka, and let them know about me, and I'm teaching over here in this class Determinant One Shot, right? And I hope you all have understood and known this part of our AIO, our beautifully designed next gen learning platform. What is this? This is the next gen learning platform by Vedantu. By Vedantu. How does it work? What is it means? It means very simple, all in one. as the name you can see, all in one. Means everything that you need to study. I know you're studying from YouTube. Great. Very good. But what happens in YouTube is sometimes you have distractions. You just keep watching endless lectures and you're not getting any output, because understand this very clearly. Just watching is not learning. What actually is learning? It's a cumulative approach to study. You have to watch the lectures, understand the concepts, revise through the notes, apply that in the problem solving, and you get that all over here. That's why it's called as all in one, starting with your lectures. So all the YouTube lectures that you see, all the YouTube lectures are uploaded in this platform. You can watch over here, are scheduled. You can see over here as well. After lectures, what you need? You need your notes. That also you'll find in the AIO itself. Yes, and after notes, what are you gonna get? You need to practice questions, sir. You need to practice questions. You'll find that also over here. And after that, what do you need? You might have some doubts. That also you'll find it over here only. So everything, our YouTube lectures, then your notes, practice questions, doubts, all will be provided or all will be available in our AIO page. Okay, and you know what is the charge of this? No charge. This is completely free for all of you guys. No hidden charges in this. Not 1, not 99, not 100, not any amount for this particular classroom, basically virtual classroom experience. Okay, so get using this right away. Very useful for all of you. How can you access? Check the video's description. Over there you're going to find the link given as free ACE KCET 2027 batch. Join that, click on that link, create a login information, start learning with us. I hope it makes sense. Okay, yes, great. So this is the same thing I was explaining, right? The system of equations. When you have 3 equations in 3 variables, x, y, and z, how to solve it using matrix method. So of course you're going to write the coefficient a1, a2, a3, b1, b2, b3. In this matrix it is called as coefficient matrix A. This is called as variable matrix. This is the constant matrix. The constant matrix. Right hand side d1, d2, d3, and this is the variable matrix. Okay. And to find, if you have this AXB, we need to find out x, right? So what we do? We write A inverse of A, x, A inverse of B. We do left multiplication of A inverse. This becomes IX equals to A inverse of B, which gives me x is equals to A inverse of B. This gives me x is equals to A inverse of B. You have to find the x variable matrix. So I have to find A inverse B. Once you get the x matrix, you'll get the value for x, y, and z. I hope this is clear. Yeah, can you move on? Let's move on then. Matrix X is the variable matrix, x1, x2, x3. A is the coefficient matrix. B is also given over here. We need to find Ax equals to, if it is given as Ax equals to B, then we have to find the x value. How do we find that? We find it like this. X equals to A inverse B. We multiply A inverse on both sides. Find A inverse, take the product with B, and you get the answer. Right? Of course, we can do that. That's the right way to do it. If it is a subjective question, but if it is objective, means we have to be creative. Let's try. So Ax equals to B, right? If this is my matrix A, what can I multiply to x? That will give me the matrix B. What it means that, what can I take? This is all given for, 4 options are given for the matrix X, right? So let's multiply this matrix given over here in the options with the matrix A. Let's try. So we have 1 minus 1, 2, and we have 2, 0, 1, 3, 2, 1. What we're going to multiply over here so that we get the answer as B, which is what? 3, 1, 4. Achha, don't check for all the elements, okay? Just check the first one. Let's try the 1, 2, 3 over here. Let's try 1, 2, 3 over here. The first option. 1 into 1 is 1, minus 2 and 6. 7 minus 2 is how much? 5. Which is not coming as 3, means this will not be there. Which means this will not be there. First option is gone. Second option. Try. Minus 1, 2 and 3. Cross check. 1 into minus 1 is minus 1. Minus 1 into minus 2 is minus 2, and 2 into 3 is 6. 6 minus 3 is how much? 3. This is correct. But let's check for all the elements also. 2 into minus 1, that will be how much? Minus 2, that's going to be 0. That will be plus 3. I get over here as 3 minus 2, that is 1. Also true. Let's check the last one also. 3 into minus 1 is minus 3 plus 4 and plus 3. 3 and 3 cancel. Answer is coming as 4. You can see if I take as option B for the matrix X, I get the result true for Ax equals to B. So yes, the right way to solve this question is using inverse, but we can also solve using product of two matrices. Is it clear? Answer is option B, minus 1, 2, 3. You have to use the options. This is faster. Okay, let's move on. So this question, it says we have 4 options. A inverse does not exist, A inverse exists, determinant of A is 2 and none of these. A is given. So whenever you have, this is what you can see over here, this is going to be simply, we can find across the third column. If I do that, I'll have plus minus plus, so 1 times of secant square theta minus, this is going to be 1, right? This is going to be determinant of 1, determinant of value A, okay? So 1 plus tan square is secant square. Identity is there. Identity is 1 plus tan square theta is secant square theta. If you move it over here, it will become secant square minus tan square. That is how much? You'll have only 1 left over here. So 1. I'm getting the value of determinant of A as equal to 1, which is not equal to 0. It means inverse will exist. Answer is option A. Answer is option A. Clear, right? Clear or not? Have a look. Clear, no? Okay. Now let's solve some PYQs based upon, from the KCET, from the same chapter, KCET. Okay, let's start. Shall we start? Yes, sir. Question number 1. Again, answer. So I want your answer right now as well. And at the last, when I finish all the PYQs of KCET, I want you to give me this result that out of these many questions, how many you got it right without my support, without my help. I want to understand that, because I told you in the beginning itself, the preparation of any chapter means that you should be able to solve all the questions effortlessly, correct, get it right. Then only we can say the preparation is actually going good. Okay, and in that case, we'll need to revise it before examinations only, not right now or always. If A is a matrix of order 3 such that A adjoint A is 10i, I told you properties questions will come. Property is what? Determinant of A times of I. Property is determinant of A times of I. So compare it. Determinant of A will be 10. Compare it. Determinant of A will be 10. They are asking us to find adjoint of A determinant. Means determinant of adjoint of A. What is the formula? Determinant of A power n minus 1, and the power of that will be same as adjoint. We have only one adjoint over here, so we don't have to write the power. Order is given as 3. So determinant of A power 2, determinant of A is 10. Answer becomes 100. Option is C. Question number 1, option is C. That's how important the properties are in these two chapters, matrices and determinant. Next, question number 2. This is again very unique question. Please remember this. Please remember this. Finding the inverse. If you find the inverse with actual method, you find the adjoint and everything you have to do. But actually, for CET, we have to save time. There's a property over here. Property is that if you have a diagonal matrix, and you want to find inverse, then simply take reciprocal of diagonal elements. Means whatever are your diagonal elements, take reciprocal of that. That will be your answer for inverse. This is a diagonal matrix? Yes, sir. Diagonal elements are 2, 3, 4, rest all is 0. So it is a diagonal matrix. Good. First condition is verified. To find the inverse, yes, we have to find the inverse. What are you going to do? look for that option which has reciprocal in the diagonal element. Okay, to take reciprocal of diagonal matrix, diagonal element, that will be your inverse. 1 by 2, 1 by 3, 1 by 4, option is D. 1 by 2, 1 by 3, 1 by 4, option is D. Yeah. So not only questions of matrices and determinants are easier based on properties, but also it ensures that you can solve these kind of questions within 5 seconds, 6 seconds, 10 seconds. And all the time you save over here, so you get it right as well. You can save time also, that can be used in calculus. And weightage, how much is this? Including both the chapters, almost 8 questions. If you include matrix and determinant, it becomes almost 8 questions over here itself. Yeah. Next, system of linear equations given over here will have what condition? Beautiful. So we'll start like this. We'll write here the coefficient matrix 1, 1, 1, and we have, we'll write this also over here 6, 1, 2, 3, over here 10. This is 1, 2, AB. Okay. Okay, for no solution, we want no solution means of course we have to start with this determinant of A will be equal to 0. No solution means determinant of A must be equal to 0. So when it will become equal to 0 when you have identical or what do you call when you have identical or simply proportional rows or column, right? When you have identical row or column or proportional row or column, it becomes what? Determinant will be 0. Check here 1, 1, 2, 2, 3, 3. If you have A equal to 3, if you have A equal to 3, this will become 0, right? Determinant property is if you have identical row or identical column or proportional row means if you multiply something with, let's say this was 2, 4 and 6, that will also be the same case, right? So if you have proportional row and column also, the determinant of that particular square matrix is what? 0. So here we have, if I put A as 3, can you check? The R2 here and R3 here will become equal. You'll have R2 equals to R3 when you put A value as 3, which means determinant of A becomes equal to 0. Because for the no solution wala case, we must have this 0 and of course the other one will be what? Other one will be when you have adjoint non-zero. Then from here we're going to get what? B should be not equal to 10. If this is also equal to 10, what happens? Check. This will become 1, 2, 3, 10, 1, 2, 3, 10. What is it going to be? This is going to be a two same lines, right? They'll become same lines. If you have x plus 2y plus 3z equal to 10, here also x plus 2y plus 3z, to put here over also this has 10. They're the same line, right? We should not have that. So for that case, we're going to put what? Not equal to 10. This will be b not equal to 10. Okay, we're going to remove that. Getting it? My answer is what? A is 3 and b is not equal to 10. Option is what? Option is this only, right? Option A. Question number 3, answer is option A. Clear? Any doubt you have, any of you, please let me know in the comment section right now. Question number 3, KCET PYQ from year 2015, year 2015. Okay. Question number 4. It says matrix A is given as alpha alpha 2 2. Then determinant of A cube equal to 27 is also given. Means determinant of matrix A to the power 3 is given as 27. Find the value of alpha. Property is that. What is the property, sir? If you have this given, this is same as this. We learned it over here. The property was A power n determinant is same as determinant of A power n. Because it's difficult and lengthy to find this value. Actually, do you know how this comes? From here. It means determinant of A into A into A into A, how many times? N times. Right? If you apply the determinant in this, what are you going to get? Determinant of A into determinant of A into determinant of A, determinant of A, how many times? N times. That's why you get the answer as determinant of A power n, right? Same property we are using over here. So we get this as determinant of A cube is what given as 27. Determinant of A will be what? cube root of 27. How much is that? 3. Determinant of A is coming as 3. This is clear. This part is clear. Find determinant from here, the given matrix. Determinant of A will be alpha square minus 4. This value is given as, we got this as 3. So alpha square minus 4. Continue. Get alpha square as 7 because 4 plus 3 is 7. You're going to move 4 over here. So alpha comes as plus minus root 7. Plus minus root 7. That is option D. That is my option D. Fourth one is option D. Please check. Fourth one is option D. Correct? Fourth one is option D. Any doubt? Put that in the comment section. Right? Question number 5 now. Evaluate this value. Yes, very easy problem. Multiply that. You get cos 15 degrees, cos 75 degrees minus sine 15 degrees and sine 25 degrees. Determinant, that's how you find. Cos A B sine A B. I think you are able to recall the formula, right? That's the formula for this? Yes, cos of A and B. What formula is this? Plus or minus? Check. Here it is minus, means this will be plus. If this is minus, this will be plus. If that was plus, it will be minus. Add them. Cos of 15 plus 75. That becomes cos of 90, I guess. Yeah. Cos 90 is 0. Sin 90 is 1. Cos 90 is 0. Having fun? Easy? Yes. Of course, there are many more questions. There are many more questions. Alright. I am solving some of them over here. If you want me to solve more questions of this, let me know that also in the comment section. Okay? Great. X, Y, Z are all different and not equal to 0. What it means? It means X is not equal to Y, is not equal to Z, and also X and Y and Z is non-zero. Because X, Y, Z, all of these are non-zero. Basically, they have not given this. They have given us this. 1 second. Yes, they have given us this. X is non-zero, Y is non-zero, Z is non-zero. So if you have 3 non-zero numbers, of course it means that product of the 3 will also be non-zero. Now they are saying it's given that determinant of this matrix is 0. They are saying that the matrix given over here is 1 plus X, 1, 1, 1, 1 plus Y, 1, 1, 1, 1 plus Z. This determinant is equal to 0. They have given that in the question. They are asking us to find the value of X inverse plus Y inverse, basically X, 1 by X, 1 by Y plus 1 by Z. X power minus 1 is what? X power minus 1 is 1 by X. Y power minus 1 is what? 1 by Y. Z power minus 1 is what? 1 by Z. Sum of that is equal to what? Getting it right? We need to find that value. Clear? We need to find that value. Okay, sir. Makes sense. Makes sense. We need to find this value. And the condition given over here is this is singular matrix or equal to 0. Determinant equal to 0. So one way to find this or solve this question is what? Expand it across any row or column and calculate it. Not a difficult method, you can do it. But I want to teach you one more technique over here which can help in some question, that is transformations of rows and column. Okay. So understand very clearly, we want to achieve this. This means what? This means what? 1 by X, 1 by Y. So we want to achieve this value. My question is to find this value. That's my question. We want to achieve this. So we'll try to think in this way only. So we'll write this matrix over here, this determinant, actually not matrix, determinant over here. And okay, let me start from here itself. And we'll take X common from the first column. From first column I am taking x common. Right here, x will become 1 by x plus 1. This will be 1 by x. This will be 1 by x. In case of matrix, when I take something common, I have to take from all the elements. But in determinant, when I am taking something common, you can take from any one row or any one column. From the first column, I am taking x common. If you are not sure, multiply back. X into 1 by x is what? 1. X into 1 is what? X. X into 1 by x is what? 1. X into 1 by x is 1. I am explaining you, slowly and giving you all the steps. But when you are solving it using this method, it will be much faster. I'll show you. I've taken x common. Same way, take y common from here. So you'll have 1 by y plus 1, 1 by z plus 1. Sorry. This mistakes can happen. And this will be simply 1 by y. Here also you'll have 1 by z, 1 by z and 1 by z plus 1. This is my matrix. So determinant, I've taken what? Y into z common. I've taken x, y, z common. But is it enough? I have created the case of 1 by x, 1 by y, 1 by z. I have this now present over here. But I'm not able to, still get that result, because to get this value, I need to produce it outside somewhere. I need to produce it at once at all the same places. Let's do one thing. Let's write the column 1 as column 2 plus column 3. Column 1 as column 1 plus column 2 plus column 3. Add all of this. Add and write. Check this out. What I'm doing? Writing this as sum of this plus this, and this is cell. So you'll have x, y, z outside beta. This outside. Determinant will become what? Check here. 1 plus 1 by x. This is the column 1 itself, and add this. 1 by y plus 1 by z. I'm adding these two as well. And the remaining as it is. 1 by y, 1 by z. Same if you do for all of it. You'll have 1 by x, 1 by y, 1 by z plus 1. You'll have same value. 1 plus 1 by x plus 1 by y plus 1 by z. This will be what? 1 by y plus 1 and 1 by z. This also will be same. 1 by x, 1 by y, 1 by z plus 1. So we'll have 1 plus 1 by x, 1 by y and 1 by z. This will become what? 1 by y and 1 by z plus 1. I have not touched the row column 2 and column 3. I have written just only column 1 as column 2 plus column 3. Understand this? The property is very simple. In determinant, if you apply column transformation, the determinant value does not change. Determinant value does not change. Will not change. So whether you find determinant of this or this, there will be simply 0 only. Because this cannot be 0, right? X, y, z is not 0. So if this into this is 0, it means this determinant value is 0. Here also same thing. If this into this is 0 means this value is 0. So without transformation also and with transformation also, the value of the both is coming as 0 only. Is something common now? Can you see? Yes. You can see in the column 1 I have the elements common. When I write this, I can write this as, check here, x, y, z, and I take common 1 plus 1 by x plus 1 by y plus 1 by z is common. Determinant is what? 1, 1, 1 left. Check. From the column 1 I have taken this element common. What I have now? 1 by y plus 1, 1 by y, 1 by z and 1 by z plus 1. Is it easier to solve this now? Still not easy. Until unless we have zeros present over here, it will be not easy to solve, the determinant. Because ultimately, check this out. This value is not 0. This we don't know about it. This is still, we don't have any clarity about it. We can't find. Can you find it? It will be very much complicated, calculative in nature, right? So I need to perform again some row transformation. Let's do it. Let us do it. Okay. So I'll do this as, I'll write it as row 2 equals to row 2 minus row 1, and row 3 is equals to also row 3 minus row 1. Let's write this. Check it out. So this all remains as it is, x, y, z into 1 plus 1 by x, 1 by y, 1 by z. And if you write this, you'll have, check this out. Row 2, so row 1 as it is, 1, 1 by y, and 1 by z as it is. Now write row 2 minus row 1. 1 minus 1, 0. This minus this is 1. If you subtract these two, what is the answer? If you'll cancel, sir, you'll have only 1 left. And subtract it over here, also 0. Row 3 also same thing. Row 3 minus row 1. So 1 minus 1, 0. 1 by y minus this, 0. And this minus this is 1. Now it is easier to find out. Check. Determinant of this is what? I told you this. If you have a upper triangular or lower triangular matrix, what is the determinant? Product of the diagonal element. So multiply 1 into 1 into 1. Determinant is what over here? This. The determinant of this particular value is coming as, let's see if this is some matrix, determinant will come as what? 1. As 1. So if you look carefully, this value beta over here is not equal to 0. This is coming as equal to 1, which is again not equal to 0. Then this must be equal to 0. If I am multiplying, check this out. If I am multiplying 3 different values and they are equal to 0, provided that this is non-zero value, this is equal to 1, then this value has to be what? Equal to 0. Correct, na? This x, y, z is non-zero value, the first bracket. The last value is determinant, that is coming as 1. Check. 1 into 1 into 1 is 1. This is 1. Though this has to be what? 0. Then only we can multiply and get the result as 0. So this bracket you see over here is equal to 0. So if you just solve this condition now, we are getting 1 plus 1 by x is what? X inverse. 1 by y is what? Y inverse. And 1 by z is what? Z inverse is equal to 0. So move this 1 on that side, you get x inverse, y inverse plus z inverse is equals to 0 minus 1. How much is that? Minus 1. I am moving this 1 over there. Answer becomes minus 1. Answer becomes minus 1. Okay? Achha, sorry. Clear, right? This is clear. Have a look. This is clear, right? Yes. If you want to solve using expansion method, you are welcome to. Sir, it took longer. Actually, it will not take longer. If you know the approach, no? What is the approach? First is to find, basically take x, y, z common from the 3 particular, columns so that we have 1 by x form. So if you take x, y, z common, it get was 1 by x and 1 by form, 1 by z form. Then you take, you add all of it, you get the value of this. You also take this common. You can see in your mind as well. Okay. So basically, and once you understand this part, this is coming, it is clearly this will be a non-zero value, non-zero value. I want to find this only, na? So I have done all of this to show you exact answer. But in the question you can see, I need to find this value, and after you take it common, you can see, you can get your answer directly from here. Your answer will come directly from here only. This is non-zero, sir. So if you take this common, and this is what is written over here, it means this must be equal to what? Minus 1. Because I have 3 factors. This factor is there, I take it common, then this will be also a factor, and then I have the determinant also as a factor. So of course this value will be what? Equal to minus 1. So in this question, you don't need to solve till last step as I have solved. You have to be smart to use the options. Check. If you compare this with 0, you're getting this as minus 1. We have 4 options. That is one of the options. D is the right answer. Right? So in CET, when you to save time, you have to be smart in the approach. But of course, when I am teaching you, I have to give you entire result. That's why I went this way. So it will be much faster if you go with the transformation method, but only solve to this part. Trust me. Because you need to find this value, right? You need to find just this value. And that is what? With plus 1. If you put this equal to 0, check here. If you put this thing equal to 0 over here only, after taking common, it becomes what? X inverse plus y inverse plus z inverse is equal to 1 goes there, minus 1. That's my option D. Making sense or not? Any doubt you have, let me know. Please check one more time before I move on. Yes. Question number 7. Again, not all will be this lengthy. So we solved 5 questions before this. This was the 6th question. We solved 5 questions. They were all very easy. 6 also was little bit smart one. 7th one, back to easy. Okay, let's go. A is in a square matrix. We are looking to find the property of this. CA. Remember this property. KA determinant is what? Kn determinant of A. What is n over here? 3. It becomes 3 power 3 determinant of A. That's going to be 27. A. Option is C. Clear or not? Yeah. Same. K, A, K is a constant, right? K power n, so K power 3, right? Option D. Can you see? We have questions for 5 seconds also. We have some questions which will take at least 1 minute to solve it. Again, if you go with the right method, it'll take maximum 40-45 seconds. Okay, you can solve it in your mind also. Yes, but to solve it in my mind, I must be equipped enough to solve. If I have solved multiple questions in my practice, then only I can solve this kind of questions in my mind. If you solve a variety of questions in the transformation side, then only you can solve a question like this in your mind that fast. Getting it? So practice is required. Question number 9. K04002. Same question we have solved, I remember, in in the subjective questions, area of triangle. I remember this. Area of triangle. Where is it? Area of triangle. 1 second. Area of triangle. Same question I remember solving. Check this question. The value of K is area is given as 4. K04002. K04002. Answer will coming as 0 and 8. Let's check this question over here we have. Okay. Yes. Here it goes. Area is given as 4 square unit. K04002. Answer will be what? 0 and 8. So that this question over here is second PU board P by Q plus KCET P by Q. And when I was teaching you this, I told you very clearly that area of triangle is a very favorite topic from the determinant chapter. It usually appears, if not every year, but actually it is almost every year only. But if not every year, almost alternate year you'll find it. Means let's say not even alternate. In the last 5 years you'll find it up to 3 questions in the last 5 years in area of triangles of CET. In boards it will come. Very likely it will come. Okay. In boards area of triangle question will come for sure. In CET, in last 5 years you'll find at least 3 questions. Minimum 3 you'll find. You might find 4 and 5 also. But minimum 3 will be there. Not the same. Area of triangle based concept question will be. Okay, sir. This is clear now how I solved it. I just solved it over there as well. How do you solve? If I have to give you the hint, half K04002 equals to plus minus 4 we're going to do, because it is area means I have to take area where I'm taking in calculation format both plus and minus. Bring 2 over there, it becomes what? Solve across this plus minus plus, so minus 2 times of it becomes what? K minus 4. This is what? Plus minus 8. Solve it. You'll have minus 2K plus 8 equals to plus minus 8. Solve this equation, you'll get the answer as K equal to 0 or K equals to plus 8. That's option number D. Option number D. Yeah. Question number 10. AB is given as I, then find the value of B. AB is given as I want to find the value of B. I'll do what? I'll take A, multiply A inverse on left hand side. Here also means left product of A inverse of the matrix. A inverse A is what? I. So I get IB equals to A inverse, which means B equals to A inverse. We want to find out B means I have to find out A inverse to get the result. How do you find A inverse? First check determinant value. 1 plus tan square alpha by 2. 1 plus tan square. Check this out. 1 plus tan square alpha by 2. That becomes secant square alpha by 2. Secant square alpha by 2 is my determinant value. What is the next step? Finding adjoint. The next step is finding adjoint of A. What do you do? Interchange. They are both 1, so it does not look like interchanged. And sign change over here. Minus tan alpha by 2, this will become plus. So tan, look carefully. Look carefully. Doesn't the adjoint looks like A transpose? Doesn't this adjoint value look like A transpose? Basically, 1 plus tan alpha by 2 has come in the row 2 column, and this minus tan alpha by 2 plus 1 comes in row 2 column. The row 1 tan alpha by 2 has become column 1. Row 2 minus tan alpha by 2 1 becomes column 2. So basically, what I'm getting over here, adjoint of A is coming as matrix A transpose. Matrix A transpose. I want to find out inverse, which is what? Adjoint A by determinant of A. That becomes A transpose by secant square alpha by 2. Secant square goes up, becomes cos square alpha by 2 A transpose. 1 by secant square is what? Cos square. So B is equal to A inverse is equals to cos square alpha by 2 A transpose. Option is B. Have a look. Option is B. Please have a look. Clear, right? Simple question. How can you solve it, sir, within 10-20 seconds? So once you see over here, it is coming as, determinant of this is coming as 1 plus tan square, it becomes simply sec square. So that will come in denominator only, 1 by sec square, that becomes cos square. So cos square is present in this step, and the last step. Look at adjoint quickly. Adjoint comes as this minus this plus. It becomes transpose. So option is clearly B. I've done entire steps because I'm teaching you right now. But in the examination, you can solve this question within 10 to 15 seconds. Within 10 to 15 seconds. And that is what is required in the exam for CET. Same property. Have you seen in the last 10-12 years, 3-4 times they have asked the same property, Ka wala property. 5A is what? 5n determinant of A, 5 power 3 determinant of A, so 125 determinant of A. Yes or no? Previous one was what? Option B, here also option B. Clear? Any problem? This is 125 by the way. 125 determinant of A. Cool. Makes sense. Clear? Next. Question number 12. Inverse. Oh my god, sir. Inverse of a matrix. This question will take 2-3 minutes to solve. Inverse of the given 3x3 order matrix. So long. Isn't it? Calm down. Let's solve the first thing, which is what? Determinant. So this is my matrix A, let's say. Let's find determinant first. So 2, let's find across 2. You'll get 3 minus 0. That's going to be 3. Find across minus 5. You have minus 5. This is coming as 0. And this is what? Plus 1. Right or not? Cross check. Across 5, you'll have what? 0 plus 1. Determinant of A is coming as 6 minus 5. How much is that? It means A inverse will be equal to what? Adjoint of A by 1, which basically is adjoint of A. Right? Adjoint of A. So how do you find adjoint of A? Basically, this is going to be adjoint of A only. So right here, adjoint of A. Write the matrix. It also be 3x3 order matrix. And for adjoint, what do? We write this 2, 5, 0, 0, 1, 1, minus 1, 0 and 3. Repeat the first 2 rows, 2, 5, 0, 0, 1, 1 and the first 2 columns. So 2, 0, minus 1, 2, 0. Here also 5, 1, 0, 5, 1. Once this is done, remove the first row, first column. After making the 5 cross 5 matrix, remove the first row and first column. Cool. Sir, do I find all of it? It will take too long. Check. First element everywhere is 3, 3, 3, 3. So don't find the first element. Don't find it. Because even if you find it, there's no point. It's not going to help. Then which is the next one? This is -1, -5, -15, -15. So means we have second element is different. Let's find the second element then. This is going to be my first element, so we'll have second element from here. Check. This will be my second element. 0 into 0 is 0. 3 into 5 is 15. This is 3 only. This will be -15. Correct or not? What we do? We find the cross product in vertical form and write the same in the horizontal rows. 3 into 1 minus 0, that's 3. 0 minus 15, that's minus 15. I did not find the first one, but you get the point, right? Just find this. So it means this is also gone and this is also gone. We don't have minus 15 over here. Now, either option B or option D. So far, so good. Now look at what are different elements. If you look carefully, you have only this element as different, -2 or +2. Just the last element, find that. 2 minus 0. 2 into 1 is 2, 5 into 0 is 0. What is the answer? So the option is the one with -15 over here, the with 2 over here. That is which option? B. Isn't this also very fast? Let me know. Determinant of A you're going to find out to check whether it is coming as whatever it is. Adjoint we'll also find out, but not for all the elements, only for what is coming as different. So be smart to use the options properly. Be smart to use the options properly. Of course, we can find for all the elements. What is the point? Why would you waste time in that? Right? Clear, guys? This is making sense? Next. Clear now? Option is B. Doubt if you have, go ahead and ask me in the chat. And do not forget to share this class with every one of your friends who will certainly thank you for sharing this session with them, because I have done everything that is required to learn and revise determinant one more time. Yeah? So, A is given, B is given, I need to find out this value. Property is there. What property is it? Determinant of A, B, B dash is what? Determinant of A times of determinant of B times of determinant of B dash. That is determinant of A times of determinant of B, and this will be same as B only, because B dash determinant or B determinant is same. This becomes what? Determinant of A times of determinant of B square. Determinant is going to find over here 2 minus 12, that becomes minus 10. B over here 4 plus 1, that's going to be 5. Put the values over here, minus 10 into 5 square. It's clear now? 2 minus 12 is minus 10, 4 plus 1 is 5, minus 10 into 25, that is how much? Minus 250. Minus 250. Answer is option C. Answer is option C. 13th is option C. Have a look. Clear? Clear? Can we move on? 14th. Question number 14th. If the value of third order determinant is 16, if the value of third order determinant is 16, okay, means order of the matrix 3, they are saying that matrix order is n equal to 3. Okay, the value of determinant formed by replacing each of its element by cofactor. So let's write that. Basically, A11, A12, A13, these values only. They are asking you to find the value of this matrix X. Find determinant of this matrix X. Achha, we know one thing for sure, that if I take X transpose, it will become what? A11, A12, A13. Again, you'll have what? A21, A22, A23, and of course other elements. So what I've done, if I take X transpose, this is what beta? This is the cofactor matrix. And this is what? This value is nothing but adjoint of the matrix A. So I'm getting X transpose as adjoint of the matrix A. They are not asking me to find this adjoint. They are asking me to find what? In the question, they are asking you to find the value of determinant of the matrix formed by replacing elements by cofactor is called as cofactor matrix. They are asking us to find, if I have taken this as X, they are asking us to find the value of determinant of X. They ask you to find the determinant of cofactor matrix, not adjoint. They are not asking you to find adjoint of this. They are not asking you to find the determinant of adjoint. What are they asking? Determinant of cofactor matrix, that is going to be X in this case. Cool, makes sense, great. So far it is clear. They want us to find this. We know that, isn't this actually equal to this? Determinant of a matrix X is same as determinant of the matrix X transpose. Correct? All of you are right with that? Yes. And this is going to be what? Right over here. Determinant of adjoint of A. I can replace na X transpose as adjoint of A. We have the property for this. Determinant of A power n minus 1. Power going to be what? Again, 1 only because we have only one adjoint. Determinant of A, we got it as 16. Power n is 3 minus 1. So determinant of the matrix X is coming as 16 power 2. This is coming as 256. Fun or not? Tell me. Was this a fun question? Something that you liked or not? They did not ask you to find the adjoint of A's determinant. They asked you to find the X determinant. What is X? The cofactor matrix. But if you take transpose of the cofactor matrix, it becomes the adjoint itself. So take this as X transpose, you get this as adjoint. Property is true for adjoint, so apply the property of adjoint, you get the result and use the answer as 256 for the matrix. Determinant of the matrix, the cofactor matrix, as option B, 256. So these were the questions I wanted to solve with all of you from the KCET PYQs. KCET PYQs. Next, one more we have. The constant term in the expansion of this given matrix. I'm looking to find the constant term. If I want to find the constant term, I don't need the variables. Take X as 0. We'll have 1, minus 1, 2, minus 1, 2, 1, minus 2, 1 and minus 1. I want to find the constant term in the expansion. So I don't need the variable. Put X as 0. Cross check 1, minus 1, 2, minus 1, 2 and 1, minus 2, 1 and minus 1. Expand it now. You get minus 2, minus 1. You get plus 1 because there is a minus sign. So you get minus 1 into 1 plus 1. 1 second. We're going to remove this, right? So we'll have 1 plus 2. Am I right? Remove this. We'll have plus 1 plus 2. 2, you check. We'll have minus 1 plus 4. Minus 1 plus 4. Let's cross check. Minus 1 plus 4. You get here minus 3. You get here plus 3, right? This is minus 3. This is plus 3. Great. This is going to be what? 2 times of 3. 3 and minus 3 cancels. My answer is coming as 6. Option is B. Clear? Makes sense? Yes. Okay. Now, time for solving some board style questions. Some PUC boards style questions. Getting it? Let's solve some second PUC board style problems. Okay, great. This is clear. What is this? Okay, a 2 marker. Find the area of triangle whose vertices are given. I'm looking to find, let's say, area of triangle ABC. How do you find it? 1 by 2 determinant. Coordinates 1, 0, 6, 0, 4, 3, 1, 1, 1. Is it? If the value will come as negative, I'm going to take what? Positive because of the area condition. You'll find across the second column itself, we'll have with minus 3, minus plus minus, right? That's why we'll get over here. Remove this, we get 1 minus 6. 1 by 3 minus 3 into minus 5, that becomes what? 15 by 2, that's going to be 7.5. It's the area, right? To square units. Please cross check your answers. 2 marker. P by Q. Boots. Find the inverse of the matrix. Also 2 marker. This is not a P by Q, this is going to be from the question bank actually. So if this is the matrix A, as 2 minus 2, 4 and 3, determinant of A will be what? Check this out. 3 into 2 is 2 into 3 basically. Minus of minus 2 into 4. I get this value as 6 plus 8, right? 6 plus 8. That's 14. Okay. Adjoint of A will be what? What we do is adjoint. Interchange this. So we'll be having 3, 2 for interchange of diagonals and sign change. So this will be plus 2 and minus 4. Right? Interchange the diagonals and sign change for the non-diagonal element. So minus 2 will become plus 2. This is minus 4. Let's find the inverse now. Final answer. Inverse becomes what? 1 by 14. 3, 2 minus 4 and 2. There's no need to multiply this because you'll not have cancellations possible for everyone. You're going to have to write this as 3 by 14 minus 2 by 7, 1 by 7, 1 by 7. If you want, you can write this. 3 by 14 minus 2 by 7, 1 by 7, 1 by 7. This is your answer. 2 marker, by the way. Again, another 2 marker question. Okay? Yes. Find the equation of the line joining the points given over here. And when we have 2 points like this, 3, 1 and 9, 3. Let's say this is the point A and C. AC is 3, 1, 9, 3. AC is 3, 1, 9, 3. I'm looking to find the equation of the straight line. How do we find it? We find slopes, sir. We can use 2-point form of the equation of line. But if this is matrix, this is a subjective question, means there will be a step marking. So you cannot use the coordinate geometry over here. You cannot use the coordinate geometry over here even though you get same answer. It will be wrong. You have to use using what? Matrix method only. Sorry, determinant method only. They have mentioned that also over here. You have to use determinant method only. Okay. So you have to assume the point B as a variable unknown xy. I can take any arbitrary point on the line as point B xy. If this is forming a straight line, it means area of triangle of ABC will be what? 0. Collinear points properties. Area of triangle ABC will be equal to 0. What is the formula over here? 1 by 2 P1 1 9 3 1 xy 1 equals to 0. Move the 2 over here. Move the 2 over there, it becomes 0 only. Now do the expansion. 3 minus y. Correct? The 3 will have 3 minus y. Now let's start with minus 1 also. You'll have 9 minus x. Check. 9 minus x. Then with 1 plus 1 will be also there. You'll have 9y minus 3x. Right? 9y minus 3x. Please check. You'll have 9y minus 3x. Correct? Huh? This is equal to 0. This all is equal to 0. Expand it. You're going to have the values as 9 minus 3y minus 9 plus x plus 9y minus 3x equals to 0. 9 and 9 cancels. You have 9y minus 3y as 6y plus x minus 3x is what? Minus 2x equals to 0. Move on this side, you get 2x as 6y. So x is coming as 3y. X is coming as 3y. If I just solve it over here, x equals to 3y is the equation, or you can write this as x minus 3y equal to 0. Equation of the straight line in 2 variables. from the point. You can verify also. 3 over here you put in x and y you put as 1, 3 in minus 3 will become 0. Okay, clear? Find the equation of the line joining the point 3, 1, 1, 9, 3. You take the arbitrary point xy, apply the condition for collinear points, which is area of triangle equal to. This is the condition for collinear point, okay? Collinear points. Got it? Makes sense? Okay. Next. A 4 marker. This is a 4 marker question of boards. So that the matrix A satisfies the equation and find the A inverse using the equation. You have to check this out, verify this, and then find the A inverse using the equation itself. Starting with verification. Come on. Let's find A square first. For you that you'll have a 2, 3, 1, 2. Same thing will come back again. 2, 3, 1, 2. Finding A square. A into A, right? So 4 plus 3, that's 7. 4 plus 3 is 7. 6 plus 6, that's 12. 2, 3 is 6. And again 6, so 12. You get 2 and 2 ones are 2 and 2 ones are 2. So 4. Then become 3 and 4. That's also 7. That's my A square. Let's do 4A now. For 4A, you're going to have 8, 12, 4 and 8. Let's try to find out this value. A square minus 4A plus I. Check. What is going to be the I value? I is 1001. So we have 7 minus 8 is minus 1 plus 1, 0. 7 minus 8 plus 1, 0. 12 minus 12 is 0 plus 0. 4 minus 4 is 0 plus 0. 7 minus 8 is minus 1 plus 1. This is coming as L matrix of the order 2. Of the order 2. Verified, na? This is verified. Verified. This is verified. Now what is the next step? Finding the inverse. To find the inverse, we'll write the equation again. Can you see inverse present over here? No. Means we have to introduce it. It will be easier if you have only I on this equation on the left hand side. We'll keep I over here and move everything on this side. Minus 4A will become plus 4A. This will become minus A square. Now you're going to do what? Left multiplication of A inverse. Right here. A inverse I 4 times of A inverse A minus A inverse of A square. What is A inverse I? Simply A inverse. 4 A inverse A is what? Not 4, it is 4I actually. What is this? You'll have to remove one of the A inverse A. So you're going to have IA, or basically simply A. 4I minus A. A inverse of A square will make it A inverse of A into A. A inverse of A will be I. You'll have another A, so IA becomes A. So 4I means 4, 0, 0, 4. And A is what? 2, 3, 1, 2. So the value of A inverse, check it out, will be 4 minus 2 is 2, 0 minus 3 is minus 3, 0 minus 1 is minus 1, and 4 minus 2 is again 2. This is the value of your A inverse. This is the value of your, okay, not going properly. Let's remove it. Yeah. This is the value of your A inverse. Answer. Please check. 2 minus 3 minus 1 and 2. Clear or not? Is this clear? Okay. A 4 marker. Also P by Q. Sorry. Also P by Q. Alright guys. Using determinant so that the points given are collinear. How do you show it? Of course, for collinear points, we should have the condition as half of this. So A, excuse me, A, B plus C, B, C plus A, and C, a plus b 1 1 1 must be equal to, we have to prove it is equal to 0. We have to find the value of this value basically. We have to prove it is equal to 0, determinant value. This is going to be what? This is the condition for area of triangle ABC. Correct now? So we can of course do the expansion, or we can apply the transformation also. If you add this with a plus b plus c, check it out. If you add this with a to this, b to this, c to this, it will become a plus b plus c, b plus, again a plus b plus c, a plus b plus c. Then take a plus b plus c common. It will become 1 1 1. If you have two rows same, it becomes 0. Check. You can do the expansion also. Method 1 will be what? Expansion. Solve determinant. Use this method only. Please use this method. Transformation is good when you know, when you have actually your, what do you call, when you actually have MCQs. Please use this method, because in your NCRT this is not there anymore, the transformations. Okay, but let me show you over here. This is simple, right? Method 1 is very simple. If you want, I can show you that as well. We'll have half of a times of c plus a minus b, because c plus a into 1 is c plus a, this will be subtraction. So minus a minus b, and with b plus c, you're going to have, sorry, with minus b plus c, you're going to have, this is minus b plus c, you're going to have what? Check, b minus c. You'll have b minus c. And with 1, you're going to have what? b square. With plus 1, you'll have ab plus b square. ab plus b square minus c square and ac. Minus c square minus ac. Solve it, please. Okay, you can solve this. This is the method I want you to use. But for this condition, let me just show you. We'll use the condition as, excuse me, column 2 equals to column 2 plus column 1. Check this out. This is going to be a, b, c. Over here you'll have a plus b plus c. Here also you'll have a plus b plus c. Here also you'll have a plus b plus c, 1 1 1, right? Take a plus b plus c common, you get 1 by 2 a plus b plus c. And what do you have? A, b, c, 1 1 1, 1 1 1. And if you check carefully, when you have two identical row or column, answer is what? 0. This is 0 means this whole thing is 0. So answer comes as 0. Hence it is proven equal to collinear point. Also a p by q. Also a p by q. Please have a look. Clear, guys? Is it clear? Yes. Finding A inverse. Exact same question. 4 marker again. How do you find it? How do you find it? So you have to show this part. 3 1 minus 1 2, same thing. 3 1 minus 1 2, right? Try it out now. This is important, by the way. This is an important question. 4 marker. Okay, easy one. That's why I've given you 2 questions of the similar category. 9 minus 1. How much is that? 8. 9 minus 1 is 8. 3 plus 2 is 5. Right? 9 minus 1 is 8. 3 plus 2 is 5. Minus 3 minus 2, that's minus 5. Minus 1 and plus 4, that's 3. Correct? Minus 1 plus 4 is 3. That's a square. Let's do 5a now. 15, 5 minus 5 and 10. Let's do 7i now. 7 0 0 7. Let's do the equation that they've given. To prove it, a square minus 5a plus 7i. Check it out. 8 minus 15, that's minus 7 plus 7, 0. 5 minus 5 is 0 plus 0, 0. Minus 5 minus of minus 5, so 0 plus 0. 3 minus 10 is minus 7 plus 7, 0. This is coming as a 0 matrix of the order 2. Check. So proven. This is verified. Proved. You have to find A inverse. Again, I told you, keep the I part over here to prove it. To find the value of A inverse, 5a minus a square. Now you're going to do what? write this as A inverse into I, and you multiply the constant 1 by 7 outside like this. This is the constant 1 by 7. Move on the other side and keep it 1 by 7 outside everything. Okay, and you're going to have over here 5 A inverse A minus A inverse A square. Correct now? I'm multiplying A inverse with I. So you have to multiply A inverse over here also and over here also. Check it out. You're left with A inverse into I is A inverse. 1 by 7 is a constant outside. This becomes 5I minus A. Check it out. 1 by 7. 5I is what? 5005. And A is what? 3, 1, minus 1 and 2. My answer is coming as 5 minus 3 is 2. 0 minus 1 is minus 1. 0 minus of minus 1, that becomes plus 1. And 5 minus 2 is also 3. We have 1 by 7. That's the value of my A inverse. That's the value of my A inverse. Please check. 1 by 7, 5 minus 3 is 2, minus 1, plus 1 and 3. Correct. Cross check. If you're getting a different answer, let me know. Okay. Acha, I have forgot to put the question number on this. Sorry. Let me do it right now. So we started from here, right? So question number 1. Okay. Excuse me. All right, sir. Question number 1. Question number 2. Question number 3. Question number 4. Question number 5. Question number 6. So let me know sixth answer is coming same or not. Question number 7. A very popular 5-marker PYQ from your board style. See, this is your last question, I think. Yeah, this is the last, right? Yeah. So can you see, we have covered every single thing for your boards, for your CET, theories, questions, properties, everything is covered. Let me know how you felt about this class once it is done, once you've covered everything, and downloaded the notes also from AIO. Okay, you have to join, you have to do a couple of things. If you're watching me for the first time, subscribe to the channel. You can see how seriously we are doing what we're doing to help you out. Second thing is also join the WhatsApp channel to get all the schedule of the classes, when it is coming live, what is the recorded sessions, what are the sessions coming to you to help you in the preparation. And the third is start using our AIO learning platform. It's completely free. Link you will find in the video's description as ACE KCET 2027 free course. Click on the link, enroll for free only and start learning. Okay, this question: solve the following system of linear equations by matrix method. We have to, what is the first step? Form the coefficient matrix. So 3 minus 2, 3, 2, 1 minus 1, 4 minus 3 and 2. Variable form x, y and z. Constant matrix 8, 1 and 4. 8, 1 and 4. This is the matrix A, this is the matrix X, and this is the matrix B. I have AX equals to B. To find X, I need to have A inverse into B. How to find A inverse, sir? Determinant of A we have to find out first. Check. 3 times of, we'll have 2 plus 3. That's, sorry, 2 minus 3, that's minus 1. 2 minus 3. So this is going to be 2 and plus 3, so it becomes minus 3. Correct. This will be what? Plus 2 because of this minus sign. 4 plus 4, that's 8. This is 4 plus 4, that is 8. And last one is plus 3. This is plus 3. Check, this is plus 3. Right? This is plus 3. From here, you get minus 6 minus 4, that's minus 10. Minus 6. Let's cross check this once to be sure. 2 plus 3, so 2 minus 3 is minus 1, correct? And we'll have plus 2 over here with 4 and plus 4, that's 8. And we have over here 3 times of minus 6 minus 4, correct? Determinant of A is coming as 3 into minus 1, that becomes minus 3, that becomes 16. And over here we have minus 30, right? So we have this as, check, we'll have over here as 13 will be this, that becomes minus 17. Determinant of A is coming as minus 17, which is non-zero, means of course inverse will exist. What is the next step? Finding adjoint of A. How do you find adjoint of A? I told you this already over here. Write the matrix 3 minus 2, 3, 2, 1 minus 1. Of course, I have taught you how to find the minor and cofactor also. I would request you to use that method. Okay, finding the cofactor and minor for each term. So we'll go like this and this. Please try this, and you take the transpose. It's a 5-mark question. It's worth it. Take that method to get out marks. Let's not take any risk. But this is clear. Okay, can I repeat the rows? So we'll have 3 minus 2 and 3, 2, 1 and minus 1, 3, 2, 4, 3, 2, minus 2, 1, minus 3, and minus 2 and 1. Okay, remove the first row and first column. Okay, multiplication in this, in the vertical form. For the adjoint, you'll write this in the horizontal rows. So it will become 2 and what is that? 2 and minus 3, that's minus 1. Again, minus 9 plus 4, that's minus 5. Over here again, minus 2, sorry, plus 2 minus 3, minus 1. Okay. Likewise, find the adjoint value. Okay. Find the adjoint value. Your A inverse will be what? Your A inverse will be, sorry, not A inverse. Your X value will be what? 1 by 17. This adjoint of A times of, what is the matrix? 814. 814. Adjoint of A, 814. Solve it and let me know what is this value coming as. I want you to solve and give me the answer. What's the value of this coming as? It will come as a 3 cross 1 matrix, a vertical or a column matrix. Give me the answer in the comment section. Answer in comment section. I can give you the answer right now, but I want to see how many of you are actually giving me my results. One homework I've given you. Give me the answer in the comment section for the question number 7 of the board style problem. Clear, guys? So this was the end of your session on one shot of the chapter determinant for the second PUC. I've done everything that you need to do to revise it properly, and do let me know how was the class, what can I do to improve it, to make it more friendly, more better for all of you, right? And download the notes and everything, doubts, clarification, everything will be in the AIO. So go and join that, start learning, with our own platform provided to all of you for free. Okay, so all-in-one platform is available. Link I've told you available in this description as free ACE KCET 2027 batch. Click on that link and start simply learning right away. Okay, that's all in this class. I'll see you in the next one. Till then, all the best. Take care. I had fun teaching you all. I'll see you again in one of the another session like this. Okay, so take care. Bye bye. All the best.